Hello and welcome to our first attack scenario here. This is going to be very much like a Hello World-esque type example of detection engineering. So we're going to get into that in a bit here. But I do want to congratulate you all on making it this far. We've gotten past all the theory, all the configuration, okay? And now we get to get into the meat of the course here with some attack scenarios and then some automation through Python. So we'll get into the thick of it pretty quickly here. So looking at our first example here as an overview, we have our Parrot OS machine, we have our Windows VM, and we have our Zeek box that sits in between and monitors all the network activity. What we're going to do on our Windows VM is spin up a really simple web server. There's not going to be anything hosted on it really. It's just going to be a very simplistic Python web server. And then we're going to scan that web server with some web scanners on Parrot OS. All right, so we're going to use Nmap, which is a very common network and port scanning tool. We're going to use Nikto, which is a aging but still useful web scanner tool. Okay, and then we're going to use Zap, which is an OWASP product. And you can think of Zap as an open source vulnerability scanner. Okay. So what we're going to do is run these scans against the web server for my Parrot OS machine. And then we're going to pivot to Elastic, look at the logs, and make a couple detections. And again, this is a very simple example, but one in which we can make a couple different types of detections and help showcase how to make this work in Elastic. All right, next up, we're going to set up the attack. I'll see you in the next video. Hello and welcome back. In this video, we're going to set up the attack for our attack scenario 1, which is essentially running some web scanners against a web server on our Windows machine, and then creating some detections based off of the Zeek data. All right, to start off, what we can do is open up Zeek. You might already have your Zeek instance running, but if you haven't, just to reiterate here, what we can do is navigate to opt Zeek. And then we're going to go into the bin. And then we're going to execute Zeek control as root. All right, and if Zeek is not already deployed, what we can do is just simply type deploy. Let that kick off. And now Zeek is good. All right, moving on to our Windows box. Let's get our Python web server up and running. What we can do is open up a PowerShell prompt. And let's spin up our web server here. You can type in python-m http.server. Okay. And you can see it's running on port 8000. Right here. So now our server is up and running, and we're going to test this in a second here. Okay, so as an example, let's say we want to make a text file. Let's just create a file that just contains some text that says this is a test, and it's going to be called testfile.txt. And we can see the file there contains that text that we put into it. All right. Now that we have that up and running, let's go to our Parrot box. And what we want to do before we start kicking off some tests is just to make sure that our web server is working as we anticipate it. Okay, so we can say HTTP, because this is an HTTP server and not an HTTPS server. We don't have any kind of SSL enabled or anything like that. It's just a very simple web server. Okay. And now we're going to type in the IP address of our Windows host, and yours might be different. Okay. But what we're going to have to do is specify the port. If you do HTTP without specifying the port, it assumes 80. And to specify the port, you could just do : and then whatever port that you need to go to. And here you can see all the files contained within the user directory of my machine. Okay. And what's interesting here, you can crawl through everything under that directory and download it as if it was just a normal web server. And if we scroll down here, we can see our test file, and there's our test file. Okay. So essentially everything under this file path is accessible through the web server. And you can see us clicking around. You can see our get documents. You can see the get test file. so you can see what server resources are getting access. All right, now that we have our Windows server up and running, we have our paired OS being able to connect to the server, and we have Zeek running. What we can do if we want just to double check that Zeek is working as we anticipate it, we can go into our Zeek.http dataset. And we can see some activity right here, okay? And if you look and compare this to our output from the web server on the Windows host, and let's go back to that as a point of comparison here, you can see an HTTP 200 on get documents and the HTTP 200 success on the test file.txt, okay? And if we go back into our Elastic instance, we can see the same thing. All right, we have the initial get for the root directory. We can see the browser's attempt at getting the favicon, which if you don't know what a favicon is, that's essentially this little image icon right here that you see on your browser tabs, okay? We can see our attempt at clicking into documents, and then we can see ourselves open up the text file.txt. If you look here, you can see us accessing that test file.txt, and some interesting pieces of information here. We can see our user agent, URL path, source IP, and destination IP. I set this up previously just to make the video go a little smoother here. But as a reminder, you can highlight any one of these, add it as a column, okay? And you'll see the data populate in your table. As an exercise, as you're going through this course in general, I would recommend you manipulating these columns and exploring the data. So for example, you can click into this log, and let's say you want to know the destination port. You can go in here, find that destination port, click this button, toggle column and table, and that data gets generated in here. These can be resized to make the viewing easier. So again, the more you get familiar with the logs and the more that you understand what fields are important and what are not so important, you can help make different views, and it'll help your alert creating process and build up your knowledge on how to pick apart logs more than just what I'm going to go through in this course, okay? And while I will show you the fields that I personally care about and that I think are helpful for alert creation and showing the information in one single view, that skill set to take a log, chop it up into pieces, and decide what you care about is an important skill set that ultimately is obtained through just doing it, okay? So all that being said, we have everything working. All right, in the next video, we're actually going to perform the attack. I'll see you in the next one. Hello, in this video, we're going to perform some attacks. And just as a recap, we're going to run some web scanners on our web server we set up in the last video. We're going to run Nmap, Nikto, and Zap. Okay, so let's move over to our paired OS box. And we can see some of the files from that web server. But what we're going to do is launch a terminal here. We're going to use Nmap. We're going to run this command as root. Write there our command in. We're going to do -sv, which scans for versioning information on the port, okay? And then since we know the exact port that we want to scan, we could say scan port 8000. And then we can supply the IP that we want to scan. Again, default password for parrot should be parrot. And this shouldn't take too long. Okay, now that our Nmap scan is done running, we can look at the results here. We can see port 8000 is open. It is an HTTP service. The Nmap is even smart enough to know that this was the simple HTTP server, which is the old module name from Python 2.7 on the http.server module that we were running, okay? So it was accurately able to determine that it was a Python web server and that it's open and that the service is HTTP, okay? And looking down another line, it was able to tell that the MAC address is associated with Oracle VirtualBox, which is pretty interesting, okay? So now that we have this scan done, we can move on to our next one. All right, next up, we can run our Nikto scan. So again, we're going to run it as root, the command Nikto, -h, essentially for host. And then you type in the IP address of your target. Instead of doing the port at the beginning, you add the port on here. So we can do our IP address : the port, and we can hit run. This might take some time, but I'll cut to the finished output once it's done. And really quick, looking back on our web server, we can see all the requests that Nikto's generated. All right, and here's the results of our Nikto scan. Overall, not that much different from our Mmap scan. Okay, but we do see there's an interesting call out here on the simple HTTP module from Python. And it also identified this downloads folder, which if we were an attacker trying to get some more data about the host, that might be a good place to look to see what kind of files would be in that downloads folder. In this case, it's just our user directory, and we don't really have to worry about it from that perspective, but it's helpful to know that Nikto tries to give you some interesting hints on what to look into next as an attacker. Okay. All right, so now we have this scan ran. We can get out of the terminal here, and let's go to applications. We're going to go to pen testing, most used tools, and you'll see OWASP Zap right here, little lightning bolt icon. So what we can do here is run an automated scan, and we're going to type in our IP address and port right here. We can click attack. You can see it's trying to do some spidering to get a feel for the file structure of the web server. Okay. And Zap, you can also have an alerts tab, which shows some interesting vulnerabilities potentially, or data about the website that might be helpful from an attacker's perspective. Okay. Going back to our web server here, you can see the request that Zap is sending over the network. And I'm going to let this run for a couple of minutes here, but after about a minute or two, you can stop the Zap scan. And to stop the scan, what you can do under this automated scan tab is just click stop. Again, after a minute or two, you should be good. Once this number of requests gets over 1,000, that's probably enough data for us to work with. Okay, so we can click stop here. All right, at this point, we have successfully run our scans. In the next video, we're going to go into Elastic and start looking at the data and seeing what detections we can create. I'll catch you in the next video. Hello, and welcome to our next video. In this video, we're going to finally dig into Elastic and create our first detection based off of the activity that we generated in our previous video. Okay, so just to start and to get everyone orientated, we are in the Discover tab under Analytics. The big question is when you're looking into certain kinds of new activity is how exactly do we narrow down this very large data set into something usable? Okay. So first off, that I like to do is look at the different data sources present in the activity. For example, right here, we have event.dataset. If it's not already in your popular fields, you can search it here. And if you click it, you'll see you'll get a nice split of all the top values for the data sources contained within this event.dataset. Okay. Since we're looking at HTTP traffic and all of our scanners are hitting that HTTP server, we're going to use the zeek.http, but this is all helpful and will guide where to pivot next. Okay. So we're going to focus just on zeek.http. So we can say, something like this. Okay. And now we get all our Zeek HTTP data. And this view, while verbose, you get the full document field here. We want something a little bit more descriptive for us. Okay. So once you get into a specific data set, what you want to know next is what fields you care about. So let's open up one of these logs. And let's kind of go through this step by step here. So when thinking about IP traffic, source IP, destination IP stand out to me, maybe source port, destination port. Okay, so what we can do is if you hover over any given field and this section right here, toggle column and table, we can start adding the columns that we care about. And now let's go to source IP. All right, so we got our source IP information, we got our destination IP information. What else is in here? We have some port. We already know that the destination port is always 8000, so I'm not going to add that to our view quite yet. We can see get. So if we see a get versus a post, that might be something we're interested in, okay? And scrolling through these logs, we can see the URL path. That's interesting because it knows what's getting targeted on the web server. And the user agent is also interesting because that typically fingerprints the browser that is being used to access the web server. And what's interesting, we can see that Nikto is advertising itself in the user agent, okay? And we'll get more into that in a second here. And outside of that, these are the fields that we care about for this log. Okay, so let's go back to our data. Now we have a nice even view here. And what we can do is reorder these. Shrink the field down to make it more presentable, okay? And this is something I would use to look at the data at a more high level. So we can see get requests, the source, the destination, on what path, and what user agent triggered the activity, okay? And this helps us paint a nice clear picture without going to each log individually, which as you can see by this hit count, that would take an awful amount of time to try to get a feel for what's going on in here, okay? So as alluded to before, this Nikto text within the user agent string is very interesting. It's something we're going to hone in on in a little bit here. But before we focus right on Nikto, what we can do is click this field statistics button. Let this generate. And if you look at user agent.original here, we could see all kinds of different user agent strings occurring here, right? And the question is, Nikto is the common theme here, but what about activity in which Nikto is not present in the logs? And let's say we would want to dig more into this other category. Okay, and now what we're doing is filtering out the Nikto text within the user agent, okay? And what we get is that other value that we saw earlier, which was a large amount of queries, but if we look at it, it boils down to only a handful of different user agent strings. So we see a lot on this specific string, and I'll give it away for the sake of demonstration, but this is our OWASP Zap scanner, okay? And then we have our Nmap scripting engine, which is also advertising itself very similar to the Nikto user agent. And what we have here is our Firefox browser from Parrot OS. So this is from us just browsing that web server, clicking around, looking at the documents folder, looking at that test file.txt, okay? So let's say we want to alert on Nikto and Nmap user agent strings, okay? We can consider this alert a port and web application scanner kind of alert. So what we can do is something very similar to what we have here. We're looking for Nmap. And we're going to get rid of this not because we only want to see values from Nikto and Nmap. Okay. And we have Nikto present. If we wanted to make sure that our logic's working here, and we can do something like this just to make sure that Nmap is triggering how we want it to. So we could add Nikto into this logic. Now we have all our data in here. So now that we have built our query to trigger on the Nmap and Nikto scanning activity, we can create this as an alert. And what we're going to do is go into our security tab here and then into manage. We can click rules. We're going to create a new rule. It's going to be a custom query. Index patterns, we can leave this as default. This KQL syntax, we're going to copy and paste from our search here. Okay. And what we want to add in is some suppression. Why that is we have almost 12,000 hits here based off our search. And if we don't add suppression in, that's going to create 11,820 individual alerts for the response team, theoretically, okay? So what we want to do is add in a reasonable alert suppression. So what we're going to do is suppress based off of the destination IP, okay? And why that is, if this source IP is also scanning another destination IP, then we want an alert to trigger on that as well. We can't suppress by the source. We want to suppress on just the destination. So if the source IP is scanning 5 different hosts, and we want to alert on each of those activity, okay, we want to make sure that we have to set that appropriately in here. So we're going to suppress on destination IP, and we're going to do per time period, okay? So we're going to run this alert every 5 minutes over the past 5 minutes. So we're going to also set the suppression for a 5-minute time period, okay? Going into name, we can really name this whatever we want, all right? Let's call this maybe it's web scanner activity, mmap and IGDO, something simple. And it detects out of the box mmap and IGDO user agent strings, okay? We can keep this as a low, keep the severity as is, and click continue. So we're going to schedule this to run every 5 minutes over the past 5 minutes, okay? We're not going to do any fancy actions here. We're just going to create enable the rule. And what's interesting is if we go into the rule settings, you have this rule preview here. And what you can do as you're creating your rule or as you're testing your rule that you already created, you can go into the rule settings and run the alert over a given time frame. All right, and let's run this alert over the past 2 days. Now that we turn back, if we scroll down here, we can see that this rule would have triggered. Okay, and that's really all we're looking for, just to make sure that the logic works. And then going back into the alert, we can look at some details here. But if you'll notice, we're missing something pretty crucial here. We're missing MITRE information. This information is actually in the About section under Advanced Settings, which we skipped earlier. And we're going to add this optional field in here. Okay, so let's look at MITRE. And when thinking about port scanning and web application scanning and the capacity that we've done in our previous video, I would consider that more discovery as a tactic. Okay, so we can select discovery. And for technique, if you're not too familiar with MITRE right off the bat, it's helpful to kind of click into each of these individually, get a feel for what they are, what they're looking for, etc. But I'll save us some time here and go down to network service discovery. If we read the description here, adversaries might attempt to get a listing of services running on route hosts and local network infrastructure devices. Okay, common methods to acquire this information include port and or vulnerability scans using tools that are brought onto a system. Doesn't 100% work with how Nmap is working, right? Because we're not importing Nmap onto the target and then running that executable. But based off of what this is looking for, network service information, we're going to get that information off the host. Okay, so we're going to use that as our technique here. Not everything aligns exactly to what MITRE says. Sometimes we just have to find the closest tactic and technique that makes sense based off the activity. Okay, and we can save that. And if you'll notice, that populates right in here. We can click on each of these and it'll bring us right to the tactics and techniques. And that concludes our first detection. All right. In the next video, we are going to create another detection based off of thresholding. And then we're going to perform our test again and then seeing if our detections worked. Thanks for sticking with me. I'll see you in the next video. Hello, and welcome to our video on threshold alerting. In our last video, we made our first query alert looking for Nmap and Nikto scanning via the user agent. Okay, and that was a very specific query where we created an alert and added in some suppression. In this alert, we're going to make a threshold alert, which essentially creates an alert on activity over a certain count. Okay, so looking at our data here, we could see a count of 30,000-ish, 50,000-ish, 25,000, and it tapers off here in the present. Okay, so the question we're answering essentially is if an abnormally large amount of network traffic is observed in the environment, trigger an alert. Okay. The big caveat here is this works very well in our lab environment because everything is nice and controlled. This isn't the best kind of alert for a corporate environment because there might be all sorts of network implications based off of the workday, based off of the time of the month, and if there are monthly scans or monthly jobs that would create more data. Okay. But just know that this thresholding type of alert can work for many different use cases. We're just using network activity as this kind of hello world first example here in this course. Okay. So how do we do this? Looking at our alerts, we can click manage. And let's go to rules. And let's create a new rule here. And instead of custom query, we're going to do threshold. And what that does is change up the settings that we put in for the alert. Okay. So if we go back to query, it just puts the query here in the suppression. Threshold, it gives us how to group and construct the alert here. Okay. So let's say we want an alert on abnormally large HTTP traffic. We can say event.dataset is equal to zeek.http, right? That's very similar to our previous alert. So let's say we want to group on source IP and destination IP. Okay, so we're honing in on just that jump there. We can say, all right, well, let's say 1,000's abnormal. Okay, we want to make sure that if one IP sends 1,000 requests to an HTTP server on a destination IP, then that's very abnormal. We want to trigger that. Maybe our other scanning rule didn't detect it. Okay. And then this alert would trigger. We can leave count as is. Let's say continue. Name of the alert. Call it excessive web traffic. All right, we could say something like this. We haven't done the schedule yet, but this is the window I'm going to use. Let's give it a medium severity. You can really leave this whatever we want. Let's give it 50. Okay. And then the minor tactic and technique, we can actually do the same thing that we did for the last alert. So we can do discovery. And let's do network service discovery. Okay. Because we're assuming it's a web scanner similar to Nikto or Nmap. All right. Give a rough investigation guide here, just telling the analyst to investigate the traffic between the source and destination IP addresses. The schedule, let's say we run every 5 minutes over the past 5 minutes. Okay. And rule actions, we're not going to add anything in here, but let's create enable the rule. And just for fun, let's use this rule preview section here. And we can see that it would have triggered. So going back into our rules, we can see we have our web scanner alert created. We have our excessive web traffic alert created. Okay. That concludes this video, but in the next video, we're going to run those scans again. and then see what generates. Okay. I'll catch you in the next video. Hello and welcome. In this video, we're going to be testing the alerts we just created in the past 2 videos. To start, make sure that your Python server on your Windows box is running, and on your Zeek box, you have zcontrol deployed. Okay. If it's been a while since you've last run these scans, you can just follow the video where we set up the attack and execute it. Okay. It's going to be more of a shorter version, and then we're going to dive into Elastic and look at our alerts. So making sure this is running here, let's now go into our Parrot OS box. And we're going to run an nmap scan on that port 8000. Now we can see some of the requests come in. And they should have that nmap user agent. Okay. Back to our scan. We can see the test was completed. And this is the same data that we saw on our first go around. Okay. So let's go to Elastic now. And what we could do is just sit on this for a bit. We do have the alert set up to run every 5 minutes. So I'm going to wait a bit and then cut the video to when the alert generates. Hello and welcome back. As we can see, our web scanner alert triggered, and there's going to be some demo here. Just going to click through this really quick, just get out of the way. All right, let's back this out. So what we can do is take a look at our alert. We can view details by clicking this expansion button here. And if we scroll up, we can see all the information that we put in the alert. We can see the severity, the risk score, the name, the MITRE values. Okay. And what's interesting is you can see Elastic attempt to create a story based off of different fields contained within the alert and the log. So you can see we have a network web event source with source IP and the source port, and the destination IP and the destination port, and it created a low web scanner activity-mmap alert. It's pretty interesting here. In this case specifically, it triggered on a post request. And if we scroll down, we can see that it suppressed 3 alerts. So that's interesting. Our suppression worked and confirmed by this little section here. And if it makes you create a test case in the first wizard, I'm just going to go ahead and delete the test cases. Not too interested in that right now. So here we can confirm our alert worked. All right. We could also look into this further. If we click the rule here, let's say it's been a while since we created it. It brings up the alert and it shows us a nice trending timeline of when the alert triggered in the past. It looks to be 24 hours. All right. So that's test number 1. We can see that the alert fired from our nmap scan. All right, now let's do this again with Nikto. Make sure that worked, okay? Now it's important if we ran just this scan again within the same 5-minute window, it'll still get suppressed. So what you can do to make sure that the suppression isn't activated is go under security into manage. Or we're going to go into this rules tab here. And we can see our web scanner activity. It was last run 44 seconds ago. Okay, so what you can do is either lower the timing on this alert. So theoretically, you could run this every minute on the minute, or you can just wait until this last run was over 5 minutes ago. So again, to save time, I'm going to cut the video here, wait till it says 5 minutes ago, and then we're going to run our Nikto test. Hello and welcome back. It's been a couple of 5-minute increments at this point. I went and took a break, and to spare you all the time of just watching the scan slowly progress, I kicked it off, and now we have the completed scan, and we can see everything that we saw in our previous test a couple of videos ago. We can see that downloads folder. We can see the simple HTTP server getting detected. Okay. What we could do is go back into our instance and we could refresh this page to see when it was last ran. All right, so we're at 1 minute. We're going to need another couple minutes for this to trigger. I'll cut the video here and we'll see what happens. Hello and welcome back. Now that our alert has triggered, we can actually see it triggered 2 alerts. All right, so we see our first Nmap scan right here, and we can confirm this by clicking the View Details button and seeing in the JSON, the Nmap scripting engine user agent. Okay. And looking into our next alert here, we can do the same thing. And we can see the Nikto and the user agent that this alert picked up on. Okay. So our web scanner alert detected both the Nmap and Nikto activity. And then since we generated a lot of web traffic from our Nikto scan, we triggered the excessive web traffic alert. And if we open this one up, you can see how Elastic doesn't really give you the clearest explanation on what's going on. You can kind of read through it based off of these highlighted fields. So we can see it's a threshold alert. There's 6,000 events within this event count, and it was triggering from the source IP. Okay. So this is great. Both of our alerts are functional and doing what we want to do. And we can move on to our last test just to make sure that excessive web traffic is picking up all our scans. What we can do is go back into Parrot. And if you don't remember, you can go to Applications, Pen Testing, Most Used Tools, and then OWASP-ZAP. Copy my IP address. We can let this run. All right, we're going to click this automated scan button here. And we're going to put in our IP address and port combination. I'm not going to kick it off quite yet. We have to make sure our threshold is passed for the excessive web traffic. Okay. And I'll cut here to save some time. All right, welcome back. Let's go back to our Parrot box and let's kick off the scan. And we could really let this run as long as we want. Okay. And we can go back into Kibana and wait to see if we have more excessive web traffic alerts. All right, welcome back from our last fast forward of this video. Okay, so once we refresh this and the alert triggers, we can see that we have a 4th alert here. And viewing the details, we can see quite a large amount of traffic. Okay. And now that with this trigger, we can go back here and stop the scan. Okay, so going back to the alert, we can see the threshold was breached, similar to our last alert from the Nikto scan. But we don't really get too much more information contained within here specific to what kind of activity might have generated this. So this is pretty generic, right? We're really just looking for a large amount of traffic, and that's about it here. And one last how-to closing out this video here. To get rid of these alerts, if you don't want to see them anymore, you can just highlight them all here, click Selected for Alerts, and mark as closed. If you have this filter set to only show open, that will prevent these from generating. If there's no open tickets, it won't let you select open. So as we do more testing and generate more open tickets, we can filter just on open, and that'll remove all these old alerts here. All right. So at this point, we've created our first 2 alerts. We created an alert on the user agent string, and then we created a threshold alert on excessive web traffic. So this concludes our first, what I've been calling Hello World example of detection engineering. I hope this has been helpful. And in our next section, we're going to go over a more complex example, and we'll make detections off of that. I'll see you in the next one. Hello, and welcome to our second attack scenario. In our first scenario, we went through Nmap and Nikto and created some alerts on web scanner activity. As mentioned in that section, that was more of a Hello World example. It was pretty simple of an attack to run. Not a lot to set up, not a lot to look at. Okay. In this example, we're going to be taking a slightly more complicated example. Our goal is to execute a return shell, but in more of a staged approach. So first, we're going to have an initial dropper. So that will be a very simple file, nothing really malicious going on in that file, with the end goal of determining if Defender is enabled or disabled. If Defender is enabled, the dropper isn't going to go and download the return shell. we want to be somewhat sneaky here. So we're trying to say, okay, download the dropper, execute it. Only download the malicious return shell if Defender is disabled. Okay. And then what we're going to do is execute that downloaded return shell. And then we're going to check out the logs in Elastic, create some detections, and rerun the test. Okay. So that's just the attack flow here, overlaying the detections that we're going to create. We're going to have a detection on the initial dropper that's getting downloaded. We're going to have a detection on the return shell that gets downloaded. And then we're going to have a detection on the return shell execution. Okay. And we're going to be writing these droppers and creating these return shells by hand and using some common offensive tooling. Okay. That's it for this overview. I'll see you in the next video where we start writing our dropper. Hello and welcome. In this video, we're going to write our first stage of the malware, which is this dropper portion here. Okay, so essentially what we're going to do is create a bat file where we can write some PowerShell code, execute it, and get some output back. Okay, let's log into our Windows 11 VM. And before we dig into the minutiae of creating a bat file and how to go about that, let's first open the PowerShell prompt and get some PowerShell working to do that Windows Defender check. We essentially need to make sure that Windows Defender real-time monitoring is disabled. Okay. So to do that, we can type in get-mp computer status. And that returns back all kinds of properties related to Windows Defender. Okay. And if we look, we can see some of these options are enabled and disabled. So we have anti-spyware is enabled. But then if we scroll down here, we can see that taper protection is not enabled. We can see real-time protection is also not enabled. And we can see behavioral monitoring is not enabled. Okay. So this is essentially the data we need to check to then execute more code if some data returns back. Okay. In our example we're doing for this scenario, we want real-time protection to be false. And then only download the dropper if that data is false, right? So to do that, what we can do is filter this down a little bit. And we could say something like, so we can say something like this. So what we're doing here is filtering on the output of this command. And we're looking at this specific property of the object. And we're looking for a like value. In this case, we're looking for the text false. Okay. And if we hit enter, it returns back all the data in a property. All right. As an example, let's say we're looking for true. Data does not return back. Okay. So this is a very simple check. We actually don't care what the data is as long as the data is coming back false. So in this example, we can say if data returns back, then execute some code. Okay. Now, how do we do that? We could create an if statement. We could wrap this data in parentheses. And how this if statement is going to work is if this statement returns any kind of data at all, this code in here executes. So as an example, we could do something like this. So we're saying if data returns back, property is false. Okay. And if we wanted to flip the logic there, you can see no data returns back. And this is exactly what we want. So essentially what we're going to do is grab the return shell from this code here. Okay. But we're not quite there yet. I just wanted to get this proof of concept code running in PowerShell. And we can use this PowerShell to start writing our bat file. Okay. So what we can do is open up a text editor. You can use Notepad or Notepad++. It really doesn't matter. To start off with bat files, if you type @echo awk, the bat file will not just print the command on the screen. It's a little repetitive, and we don't need to see the commands repeated back to us in the console. Okay. And now what we can do is start adding in some PowerShell. So when using PowerShell via a bat file, you have to add in some characters here. And here's an example of how this would have to be structured. And what we could do is just kind of insert our code right in here. If we go back, we can grab this statement and throw it in here. Okay. And now what we can do is type in pause so that once we execute this bat file, the command prompt will just execute and shut before we see the data. Okay. And I'll show you an example of that really quick here. But to test this, what we can do is just call this something like this. And we can save it as a batch file. Okay. So you can see some text highlighting here. That's great. And what we can do is run this now. And you can see no data returned back. All right. But now let's see if we set this to false. All right, so it didn't like my function there. You can see it pops up as we'd expect. And then if we press any key to continue, it then closes that out. All right. If we ran this without the pause and execute our file, you can see it executes. We see the blip and then essentially closes out. But if anything more complicated was happening or we need to see the output, we do want that pause statement in there. Okay. So now we essentially have a functional bat file. I would call this version 1.0 of our bat file, where it's running a check against MP computer status, and then it's checking the real-time protection enabled property, making sure it's false, and then executing some kind of code. Okay. At this point in the video, we're going to cut it off here. We have a bit more work to do that I'll save for part 2. Thanks for sticking with me. I'll see you in the next video. Hello, and welcome back to the next video. So now the question is, how do we try to weaponize this? Okay. So let's go to our Pair OS machine. And essentially what I just have here is a text file. It's a text file just containing some sample text. It really doesn't matter what it is. We're just attempting to make sure that we can transfer this file from Pair OS to our Windows 11 machine. Okay. So what we can do is start a simple HTTP server here. And what we want to do from our Windows 11 host is to grab this file and place it in a given directory. Okay. So to do that, let's work with it a little bit in the context of the PowerShell command line. Okay. So to download a file via PowerShell, we could use something called invoke web request. And how this works is you can give a URI. And this is the IP address of our Pair OS machine. Okay. Remember, it's on a different port than just 80 or 443. Okay. So we're on port 1000 and we want that test.txt file. And let's say we want to place this file in a more obscure directory that we could then refer to later. Okay. And let's say we want to put the file in Windows temp test.txt. If you notice, it went and grabbed the file very quickly there, and we can navigate to that directory and see what's there. So C, Windows, temp. We have this test file. It was created just now. And if we look, we can see the bad code text here. All right. So this essentially is a proof of concept code on how we can download a more malicious dropper. Okay. So what we can do, just to make sure this is working how we want it, is let's delete this test file here, and let's insert this into our PowerShell code. And to make this easier to see, I'm going to word wrap this. All right. So we should be able to just copy and paste that code in here. All right. Now let's run this batch file. All right, it executed. And let's see here. And there we go. Okay. So now this is another iteration of our proof of concept code for our bat file. We now are checking for real-time protection enabled. And then we're actually grabbing a file from our parent OS machine. It's just a text file right now, but it's not something that's overtly malicious. Okay. But we're going to change that. All right. So let's take this weaponization one further step here. Okay. In our parent OS machine, let's open up another tab. And what we're going to do is create some PowerShell code that, when executed, will create a return shell for our parent box. Okay. So let's create this PowerShell code. We're going to use a program called MSF Venom, which is part of the Metasploit framework. This is a tool that you can create all kinds of payloads for different kinds of operating systems, web shells, architectures. For our scenario, we're just going to use the reverse PowerShell payload. Okay. And next up, what it wants is something called lhost, which in the Metasploit land means listening host, which is just going to be our parent OS virtual machine. Okay. And then we're going to need a port. It really doesn't matter what this is. We're just going to use 8443 as an example here. And then we're going to pipe this out to something called shell.bat. Okay, so if you notice here, we now have a shell.bat file. If we look at it, we can see a bunch of PowerShell written in here. Okay. And this file is now being hosted on our server. All right. So the next question is, how do we facilitate this kind of execution? All right. So instead of looking for test.txt, we're going to look for shell.bat. We're also going to store it in the same directory. Before we do anything further, let's save this, run it, and make sure we see a shell.bat file sitting in here. Okay. And there we go. There's our bat file. If we run it, it will send a request back to our paired OS box for a return shell. But I don't want to really set that up quite yet here. What we're going to do is just delete these files here. Let's get rid of this pause. So before we kick this off, we have to get the listener set up on our parent OS machine. So let's open up a new tab here. Okay, so we can actually do it right from here. You can type in sudo space msf console. And this will start up the Metasploit framework. We're going to use exploit/multi/handler. You can type in options and see the different settings that you have to configure. We have to set a host and port. All right. So this is going to be the IP address of our parent OS machine. And we're going to do the L port of whatever we configured via MSF Venom. Okay. If you remembered, we used 8443 as our port. So we can set that. So at this point, Metasploit is fully ready to receive a connection from our Windows 11 box. All right. The question is now, how do we go about executing it? All right, so we're running our check, we're grabbing the file, we now have to execute it, okay? And what we can do, very simply, is put a semicolon and then another command. That's how in PowerShell you could do multiple commands on a single command line, okay? So what we can do is just copy this text right here, and that should get off for us. All right, so pretty simple. Key point here being, if there's multiple commands you're going to run, you're going to need a semicolon to separate those commands out. Okay, so let's run this batch file. All right, and now back to our reverse shell. We can see we're now on C users desktop. All right, so who am I? We are the user. And you can see the host name of our Windows 11 machine. Okay. And you can run commands in here just as if you were on cmd.exe on the Windows 11 machine. So this is essentially our first attack. All right. But we're not quite done yet. What I want to do next is make this a little sneakier. As an attacker, we don't like sending BAT files over the network. We want to send something more generic like a text file. Okay. We can do that. First, what we want to do let's rerun our multi-handler here. Okay. But let's go back to our server. So we essentially want to make this shell.bat just a text file. So what we can do is open a new tab, do mv for move, and rename shell.bat to shell.txt. Okay. And now what we're going to do is edit our script here. So instead of shell.bat, we're actually grabbing shell.txt, but we're saving it as a bat. Okay. And this is a very simplistic example of an attacker obfuscating their activity. Okay. So the key point here is they're grabbing data in one way and then saving it and executing it in another way. Okay. So let's save this and let's execute this again. All right. Now let's go back to our handler and we can see another session opened and we still have command line activity. But the key point here is the only interaction that happened over the network is via text files. Okay. And at this point, we have both set up our attack and performed it just by the nature of us creating the POC code and going through this whole iterative process of starting with get MP computer status and then getting return shell on our box. Okay. That's it for this video. In the next video, we're going to go into Elastic and see what kind of activity this generated. And then we'll make some detections and re-trigger this activity to make sure we have good detections. Hello and welcome. In the last video, we made our BAT file, was checked to make sure that real-time protection was disabled, and then downloaded a return shell from our box and attempted to do some light obfuscation of the activity. So what we're going to do next is go into Elastic, and let's see what kind of activity that generated from our testing. All right. So if we go into Discover, you can see some logs here from all the activity that just occurred. All right. So what we can do is look into specific data sets. So let's start with something simple. Let's first look at the Zeek HTTP logs, similar to the previous section. Okay. All right. So we have our logs here. Let's look at the exact fields that we care about. So let's do get. Let's do the response code. We want the URL path, the extension, and maybe some user agent information. And maybe want some networking information here, let's say the destination, okay? So making this a little bit more manageable to read here. So here's a really good view of all the testing that we did in the previous video. So we can see our initial text test files, okay? And then we can see the first couple shell.bats that we sent over the network. And then we can see our more obfuscated attempt where we sent over something called shell.txt, but it's being identified by Zeek as a text file, but then we were saving it as a bat file, okay? So there's a little bit of nuance there. We can see the activities here. Just looking at this data, one possible detection is to alert on suspicious bat files being sent over the network. If you actually looked at something like this in a corporate network, there might be all kinds of bat files getting sent around for different kind of automation used by, let's say, help desk or sysadmins or things of that nature. What you might be able to do is create an alert on bat files and then whitelisting out some of the sources or destinations. Okay, so if you have a singular server that's hosting all those approved files that help desk or sysadmins use, maybe whitelist out those destinations, and that could be a really good potential alert. Okay. You can also have an alert on maybe bat files on abnormal ports. So let's say any bat file getting sent over the network not over port 80. That might be a reason for consideration as well. It really depends on the company you're in and what's considered normal. Okay. So what we're going to do in our next video, based off of this activity, is to create an alert that will trigger on bat files observed on abnormal ports. Okay. The fun caveat with that one is that alert will not trigger in our more obfuscated code. Okay. But once we test the alerts, we can do it one way to make sure it triggers, and then run it the other way to make sure that our obfuscation as an attacker was bypassing the detection we created. Okay. And that's really a key point I'm trying to drive home here is in the cyber defense world, it's a constant battle of cat and mouse on detections that you create, and then attackers find different novel ways to bypass the detections you might have created, and then you'll have to write more detections to alert on those activities and so on and so forth. Okay. And that's what we're trying to emulate here. All right. So that's the Zeek HTTP dataset here. Pretty simple. Let's go back to our data and clear this out here. Let's get rid of the selected fields. And let's look at our data set again. All right. So looking at Windows System on operational, this provides a very clear view of what's going on. All right. So what we're going to do is look at some of these. And let's do parent command line, parent name. Okay. And if you notice, a lot of the data here isn't populating. So what we want to do is filter out blank data. So we're narrowing down our view to find what we want. All right. And just doing scroll down here, we can see a lot of Windows activity. And if we keep scrolling, we can start to see some more suspicious activity. Okay. And if you notice, this is actually following exactly the kill chain that we developed. All right. So let's look at the 3 logs here, going from oldest to newest. All right. So we have cmd.exe is executing this testing.bat. And then we have PowerShell that is then getting executed. Okay. So it's an interesting chain of events where we have a bat executing PowerShell. Okay. And if we expand this out, you can see the full text here. So this is the exact script that we wrote, and we can make some detections off of this script. Okay. Okay. So looking at this bottom log line, you can see testing.bat is getting executed by cmd.exe, which is what happened when you double click to run a bat file. Okay. And then what's happening is it's then executing the PowerShell, and going up a tier, we can see PowerShell getting executed. We can see that same command. And then we can see through this command where it's executing that bat file, that bat is getting executed here. Okay. And going up another line, we can see the contents of that shell getting executed right here. So we can see this is that MSF Venom payload that we created. Okay. So what's really fun is you can see the entire chain of events that we worked on in our last video. Okay. So now that we see that we have the visibility, right? We can see the exact chain of events. How do we go about creating detections off of this? There's a lot of different ways that you can go about your detection creation process. You can be very explicit. Okay. So you can say, all right, well, we observed testing.bat in the wild. Let's take these 3 log lines as an example. Let's say these are involved in an active investigation with the response team. This is something we know about and we want to monitor on very specifically. Okay. We can say, okay, we've observed an attacker using testing.bat. Let's make an alert on any hits where testing.bat is executed. Okay. We could go down that route, but it's missing some nuance. All right. If let's say the attacker called the next bat file testing2.bat or example.bat or really anything else beyond testing.bat that would bypass the alert. So ultimately, that's not the best kind of alert you want to make. If you do need to make something like that, you could always have a time to live on. And so let's say you're monitoring for that kind of activity for maybe 30, 60, 90 days, and then you retire the alert and assume the attacker has moved on to greener pastures or different techniques or things of that nature. Okay. But what we can do is be a little bit more abstract in how we're alerting. So instead of being super explicit, we can say something more generic. We can say, let's execute an alert if PowerShell is observed executing from a bat file. Okay. That could be a little bit more indicative of malicious activity. Okay. And it's a little bit more all encompassing. Okay. So if they rename this file, it would still trigger. And that's really what we want to see. Okay. But like I said earlier, there is a balance there. If PowerShell is frequently being used in your environment for IT or sysadmin usage, then that would trigger on those alerts as well. And you'd have to work on some process to tune those out. All right. But for a course, that's definitely not going to be a problem. Okay. So it's going to be alert number 2. We're going to have PowerShell being executed through a bat file, and that will be an alert. All right. And looking at the same log, we could also make an alert for bat files getting downloaded over invoke web requests. Okay. This is going to be a pretty interesting alert because thinking back to our network traffic alert example, if someone is doing this little rename trick here where they're saying shell.txt and they're renaming it to shell.bat, this would bypass that network alert where it's relying on this extension. Okay. But the endpoint alert would still detect it because we can look at shell.bat getting downloaded through an invoke web request. Okay. And that will be alert number 3. And if we go up to our next log here, we can see our MSF Venom payload. There's a lot going on here, right? But what we can do is search for key pieces of this payload and trigger on that activity. So essentially what we're making alert for is default MSF Venom payload generation. Okay. And that would be specific to this PowerShell payload, but it would trigger on that activity. All right. And to do that, we can search on large chunks of text that are contained within this activity. All right. So for example, the only variable piece of information that MSF Venom generated were these variables here. All right. But if you notice, the C variable has nothing to do with the input that we gave MSF Venom. Okay. And if you kind of scroll through and read over it really quick here, you can see that all of this is out of the box what MSF Venom does. So we can alert on a large chunk of this text, and that could be considered a default MSF PowerShell return shell detection. Okay. And that will be alert number 4. We're going to dig into all that more in the next video. Okay. Thanks for sticking with me. I'll see you in the next one. Hello and welcome. In this video, we're going to create 4 detections based off of the attack scenario we worked through in this section. Okay. And as a recap, our first detection will be bat files being detected in HTTP data on unusual ports, meaning anything that's not port 80. Okay. Our second detection will be PowerShell execution via a .bat. So essentially, whenever a bat file is then triggering PowerShell, that will create an alert. Our third alert will be detecting the invoke web request function of PowerShell downloading a bat file. And our fourth detection will trigger on MSF Venom's bat PowerShell return shell. Okay. So to start, let's look at our HTTP data to knock out this first alert. We can say event.dataset is zeek.http. Okay. And just reviewing these fields really quick here, we can see our file path and then the extension. And we want to look at the extension. And since we're triggering on unusual port activity, we want the destination port. Okay. So just looking at these, we essentially want to trigger on activity where a bat is observed in a port that is not 80. All right. And to write this, we could do something like this. And you can see it narrowed down our results here. And this will be a great way to alert on this exact activity in our example. Okay. So let's turn this into an alert. We can go to rules. And let's create a new rule here. This is a custom query. We're going to put our search right in here. All right, so going back to here, we can grab that text, throw it in here. And for suppression, let's say we want to suppress via the source IP. That way, multiple bat transfers won't trigger a bunch of alerts, but it'll be enough for the response team to go look into it. But if another source IP reaches out to the same destination, then it'll trigger an alert. Let's say we're going to suppress for 5 minutes. We're going to continue. And name, we can really call this anything. We can call it something like this: bat files observed in HTTP traffic on unusual port. Okay. And description. We could write something a little bit more descriptive here. Okay. Severity, we're going to keep this as low. We're going to keep the default risk score. And if we go into advanced settings, we can add in our MITRE information. And we think about the MITRE attack tactic and technique. Okay. This could really depend based off of the mechanism that this bat file was downloaded. Okay. So one example could be a phishing link that downloaded the file. It could be an advertisement on a website. It could be a website link they clicked and then downloaded the file. Okay. It could be a wide variety of things. And each one of those has a different tactic and technique associated with it. But if we go into the MITRE matrix here, when I think of a bat file, I think about its execution. I also think in our scenario, we're looking at the initial access vector, but these techniques don't 100% line up with what is occurring in our scenario. Okay. Though the file is not executing in and of itself, this Windows command shell sub-technique here does fit pretty nicely. Okay. So essentially we're looking for execution of a bat file. All right. And sometimes the MITRE tactics and techniques don't 100% line up with what you're looking for, but it can be close enough as a talking point. Okay. So let's use this technique. So we're looking at an execution, and then let's look at command and scripting interpreter and the sub-technique of Windows command shell. Okay. And scrolling down, okay, continue. Now let's schedule to run this every 5 minutes, looking at the past 5 minutes. And rule action, we're also going to leave this blank. What we can do is run this rule preview and see what comes up. And we can see it would have triggered. So this rule we're going to consider good. Let's create and enable it. All right, and here's our first alert. Now what we can do is go back to this page to get ready for our next alert here. All right, now let's go back into our Discover panel. And what we can do is start clearing this data out. Okay. So next up, we're looking at PowerShell execution via a bat file. All right. All right. So first off, what we want to do is filter on one of these data sets. We want the sysmon operational logs here. Okay. You can see windows.sysmon_operational. And what we can do is just throw in a general search just to get our activity more visible. And we can see a bunch of data in here. Okay, but let's make this a little bit more visible to see what we want to see. All right. This looks a little bit better here. And if we look, what we're really trying to trigger on is this log right here. So we can see a bat file is executing some PowerShell. Okay. So what we're going to do is first look for the PowerShell in the command line and then the bat in the parent command line. Okay, and we can do that pretty easily. If we look at our search here, so we're saying event dataset is the sysmon_operational and process.command line starts with PowerShell. Okay. And process.parent command line contains bat. And the process parent name is cmd.exe. Okay. So what we're looking at here is the bat getting executed because by default, if you double click on a bat file or otherwise execute it, it spins up cmd.exe. Okay. So that takes care of the parent bit. And then for a process itself, we're looking for PowerShell kicking off the command line here. Okay. And if we scroll down, we can see that this is consistently hitting on our activity and the test. All right. So this is going to be the foundation for our next alert. Going to rules, we can kick this off here. Let's copy and paste our query. For field suppression, we're going to go by hostname. If we look here, the field is called host.hostname. Okay, so that way, if a bunch trigger on one host, it won't overwhelm the response team. And we're going to suppress for 5 minutes. But if this happens on another host, that'll trigger its own separate alert. Okay. For the alert name, we can say something like PowerShell execution via bat file. Maybe something like that. We're going to keep all this as the default values. Under advanced settings, we can see our MITRE attack, tactic, and technique section here. I'm going in, instead of Windows Command Shell, what we can do is navigate to the PowerShell version. Okay. So similar to the last alert, we're going to go to execution. And this time, this actually is execution versus what we kind of made fit for our previous alert. All right, we're going to call this command and scripting interpreter. And let's do PowerShell. All right, going to leave all the rest of this blank. We hit continue. And we do need a description in here. So adding in here, we can say we could say something like this. So we're giving a little bit more description on how this is working without looking deep into the logic. Okay. And scrolling down, we can continue the alert here now. And let's make this runs every 5 minutes, looking back 5 minutes. And before we create and enable, let's go back up here. Run this for today. All right. And we can see some activity based off of all our testing. All right. So we can create and enable this rule. And there we go. All right, going back to our search here, we're actually going to stick with this data set. We're just going to look for a different activity here, okay? So our next alert is looking specifically at that invoke web request function here, okay? And if we were to looking at this more generically, we can say something like, we now have some more information that isn't exactly in our previous search. So we can actually see the invoke web request, then downloading a file. So in this case, we're more interested in this log versus this log, okay? Even though invoke web request is contained in both, we really want to see the PowerShell activity, okay? And not just text observed within a bat file. So what we could do is say something like this. And now we're getting really specific on what has to occur. So now PowerShell has to call the invoke. Okay, so we can see 2 hits that would show up under our final query. Okay, so let's look at this log. And looking, there's really 2 places we can search. We can look at the specific parent.org. We can look at the parent args or the parent command line. Parent command line is a little easier to work with. So let's use this. And that filters down invoke web requests being triggered through PowerShell, which makes sense because it's a PowerShell function. But the thing is, this looks great in my test environment, but we want to get a little bit more specific, okay? Because this is a very common function to be used. So what we can do is ensure that only bat files are getting detected from this activity. And the same data returns back, but we know that this is more specific, okay? So if someone is using invoke web request to download a text file, this won't trigger. We just want to be intentional about what we're triggering on, all right? So what we can do is now work on this alert. The data in here. And similar to our other one, we're going to suppress based off of the host name for 5 minutes. We can call it something simple like this. All right, so we're being a little bit more specific here. So we're describing the data set we're using and exactly how we're triggering, okay? So the key point here is we're just triggering off of those strings. Theoretically, if someone triggered PowerShell with these strings and not actually using those functions or a bat file itself, it would still trigger a false positive, but that's pretty unlikely, okay? And going down here, let's go in advanced settings. And similar to previous alerts, we're going to execution, command and scripting interpreter, and we're looking at PowerShell. All right. We can schedule this 5 minutes every 5 minutes. And let's go back up here. And run the role preview, and we can see it would have triggered. Now we can create and enable. And there's our 3rd alert. All right. Last but not least, we're operating off of the same kind of information, but now we're looking at the default MSF Venom PowerShell return shell activity. Okay, so let's back this up a bit. And as a generic search, let's look for any logs containing PowerShell. Okay. Let's scroll a bit here and we can see our return shell. All right. Expanding this out, we can see a lot of data in here. The key point is that this text is static, as well as everything after the given IP address and port that we use when setting this up in MSF Venom. Okay. So there's a couple ways we can go about this. We can look at this whole string going down here, or we could do something smaller and maybe triggering just on this here and assuming that if we see PowerShell-W hidden, nop-C with this specific combination of characters here, which is $A equals, and then whatever variable here. Okay. This might be good enough to trigger on the MSF payload. Okay. So how do I make this work? We want to trigger just on cmd.exe. And if you notice, there's quotes in here, so that makes it a little more complicated to set up. So I'm going to copy and paste my query in here. So breaking this down, we're looking at process.commandline is equal to cmd.exe wrapped in quotes. If you notice, I had to escape these quotes here. All right. And what's interesting, in this case, I'm actually searching through message. If you notice, I'm not looking at the parent.commandline. And the reason for that is if we open this up, let's go to that field. It's flagged as an ignored value because this field is too large for Elastic to want to search over. Okay. And there's configurations to bypass that, but that's a little out of the scope of this course. But what we can do is just search all of the message data, which is essentially the raw log. Okay. So what we're doing here is instead of searching the parent command line, we're now searching this whole message field for this chunk of text. Okay. And we can see here the data is returning back as expected. So let's make this an alert. This is another custom query alert. And let's grab our search here. We're going to also suppress by hostname. For 5 minutes. So for the alert name, we can be confident and say this is MSF Venom, or we can say potential MSF PowerShell payload observed. Okay. So something pretty basic here. All right. Now for our MITRE tactic and technique, while what happens after this return shell completes and the actions on objectives that the attacker is doing on the box, that could be really anything, right? Once you get command shell execution on a box, you can do all kinds of things like data encryption, data exfil, and those are all different tactics and techniques. But essentially what's happening here is just PowerShell. Okay, so like the other ones, we're going to execution, command and scripting interpreter, and PowerShell. Okay. We're going to leave all this blank, hit continue, 5/5, like the other alerts. Okay. And before we're done here, let's run this in the roll preview. And we see our hits. All right, let's go down here and we can create and enable. Not too sure what went on there, but just hitting it again. Let me create the alert. All right. So now looking at our alerts, we have our 4 alerts created and they're ready to go. I didn't really specify any kind of risk score or severities. We're not too worried about here. We just want to make sure that these are triggering properly. Okay. And at this point, this video has gone on a little long here. Hopefully this was helpful. In the next video, we're going to execute our batch script again, perform the return shell, and then see what generates. Thanks for watching, and I'll see you in the next video. Hello and welcome. In this video, we are going to run a quick test just to confirm our detections that we created in the previous video. Okay, so to start, so in Parrot OS here, you notice I don't have a shell open. We actually don't need the return shell to function. We just need the code to execute on the host. So I'm not too worried about that. So in your testing, you don't actually have to have the exploits always work as long as the code executes on the boxes that you're testing on. Okay. And looking back, we're in our Elastic instance here, and we can see we're in our alerts tab and nothing is generated in the past minute, which makes sense. Okay, so let's now go into our Windows box here. And we can close out of all this testing from our previous video. So we have this testing bat file here. If we execute it, it'll run all the fun stuff that we've created in this section. And let's get this going. All right, all the code should have executed there. We should have 3 alerts trigger. All right, and you may be asking why did 3 alerts trigger when we created 4? The answer is because when we work through the obfuscation section of our bat file here, we can see we're actually grabbing the text file and creating a bat out of it versus the bat file in transit. So we're actually not going to trigger this alert through how we made this bat file. Okay, but what we can do, if we were curious, let's say we edit this to say shell.bat, save it, and run this again. If you notice there was an error there, what we have to do, we previously moved the bat file so it no longer exists. So now we can just copy the file. We have both files existing. All right. And now we could run this and grab the shell.bat. And there we go. If we go into the folder here, we can see our shell exists. All right. And what we should see is a bunch of alerts now in Elastic. Once it triggers in about 5 minutes or so, we should see a handful of alerts from running this bat file 3 times. So we should see 3 individual alerts for that activity. And we should only see 1 for that network related alert. Okay. In which we're looking for that bat file in transit through the zeek.http data source. Okay. So what we could do is just go back to our alert section here, and we can keep refreshing it. We can see our 1 alert triggered here. So we can see the bat file that just happened to trigger first out of the chain of events that need to occur. And what we can do is pop open this manage tab, go into rules, and we can see when these were last run. I'm going to have to let this bake for a couple of minutes here, but I will fast forward the video once the alerts have populated and we can talk about it. Hello and welcome back. You can see the output of all our testing. Okay. And if you notice, we don't have as many alerts as you might initially think, and that's because of our suppression rules. Okay. So we're suppressing based off the host. So we could have triggered that executable 100 times on the same host within a 5-minute period, and it would have still only triggered 1 alert, which is what we intended. Okay. So looking at our activity here, we can see our 4 alerts trigger. And this is exactly what we want to see. So we can walk through them. We can see everything being displayed, how we set it up. And we can see the relevant pieces of log data that gives the response team something to start looking into. All right. And we can see our 1 suppressed alert. Going to our next one. We can see the invoke web request downloading a bat file. And in the process arrows, you can see the exact file location and the name of the file. This is really helpful for the response team because that lets them know where to go look for that bat file in case they want to investigate what the contents is. Okay, so let's say we only have this, but we don't have the execution of that bat file. In that scenario, the bat file was never executed. Maybe there's a timer. Maybe it only runs once a day or runs on startup. Okay. In that scenario, the response team could potentially find that bat file, grab it, investigate, see what's in it, make sure it's not malicious, and get rid of it before it has time to execute. Okay. We can see 2 suppressed alerts, which makes sense based off of how many times we clicked on that bat file. Okay, so we clicked it 3 times, and we have 1 alert here and 2 suppressed. So the math checks out. All right, going to our next alert here, we have PowerShell execution via a bat file. And we can see all the information in here, and we can see the exact PowerShell and the process args. All right. And again, 2 suppressed alerts. And our last one, we have the MSF PowerShell payload observed. Okay, this one's a little tricky to look at because we don't have a dump of the information. And this is an interesting example where sometimes Elastic doesn't give you everything you need right out of the gate. Okay, so in this scenario, we want to go about this a couple of ways. We can add an investigation note with some more detail. We could put something in the name to tell them more where to go. So for example, we can say potential MSF PowerShell payload observed in message field. Okay. And that lets them know, like, okay, I need to see the message field. How do I do that? So Elastic in the overview only gives you the highlighted fields. And there's a couple different ways to view all the fields. You can go into the table. And let's say we want to type in message. Okay. If we hover over this message here with this 3 dots here, we can see the whole message field here. It's a little awkward to look at. Okay. You could also copy to clipboard and view it there. Or you can go into the JSON and you can control F for something like $A, which is part of the query. And then we can see all the data in here. Okay. And typically I like going right to the raw log itself. So this table, while helpful, doesn't always do what you want it to do, but the JSON is just JSON. Okay. It's easy to query. You just control F, or you can just copy and paste the JSON off to somewhere else and manipulate it that way. Okay. And what's fun, as a little bonus content here, we have 2 alerts on malicious behavior, suspicious PowerShell execution here. Okay. And this is a critical with a risk score of 99. Okay. So whatever's triggering this is pretty certain that this is bad. All right. If we look into it, we can click this here to go look at the rule. Let's check this out. So this is endpoint security. All right. So what is happening is we have Elastic Defend integrated into the Elastic agent, and that is on our Windows box. But if you remember at the beginning of installing our agent, what we did was turn Elastic Defend into detect only mode. All right. So this creates a detection, but doesn't really do anything with it. If we switched Elastic Defend and endpoint security from detect only to block, it most likely would have actually blocked the return shell from executing at all. Okay. So that's pretty typical of EDR products where things that are out of the box, like MSF Venom, Metasploit, things of that nature without any kind of obfuscation or attempting to be tricky in how it's operating and executing, it will often block it. Okay. But in our example, we're doing things pretty basic here. We disabled security. We have everything as detect only. Okay. We allow script execution, all kind of fun stuff you really would never want to do in a real environment, but works great for our test environment and this course. Okay. So this is just a good example of Elastic detecting this activity out of the box without really any configuration. All right. What's interesting to note here, we have 3 detections that we created versus the 1 that Elastic found. The Elastic really only found that final piece of the puzzle. Okay. And if we scroll through the JSON here, we can see that it's detecting that MSF payload. Okay, so Elastic, for all intents and purposes, didn't care about the bat files getting downloaded or anything like that. And one last thing, as we scroll out in here, what we can do is look at this Analyze Event button for any one of these. Okay, so let's look at the potential MSF PowerShell payload observed really quick in this analyzer. If we zoom out here, we can actually see a pretty large chain of events that Elastic is correlating out of the box, which is really neat. So if we go to cmd.exe, we can see that testing.bat executing. It's executing PowerShell, and it's running these commands. Okay, so we can see it grabbing the file and executing the file for the return shell. Okay. Next up, we see the execution of that bat file, which was spawned by the PowerShell. That bat file is now executing our interpreter payload. Okay. And then finally, that interpreter payload is getting executed through cmd.exe. All right. So a really interesting, powerful way to view how this is all working. You can even see timing between each of these hops. Okay. So this is a great tool. If we weren't the ones creating this activity, generating and executing it, okay, we already have an in-depth knowledge of how this is working. But if you're coming in fresh and you only see this final hop here, it's really powerful to be able to look back and see exactly the chain of events that led to the activity that spawned the investigation. Okay. All right. This concludes our attack scenario 2, where we set up a more complicated example to walk through the detection creation process. Okay. In the next section, we're going to do something similar, but a little bit more advanced in the kind of activity that we're looking at. Okay. So similar to how attack scenario 1 was a little bit basic, and then in this section, we have something a little bit more advanced. We're going to make another hop similar to that in the next section. All right. I hope this has been helpful. Thanks for watching. I'll see you in the next section. Hello, and welcome to our attack scenario 3. If you remember, in our last scenario, we created a bat file that checked to see if behavioral monitoring was enabled. And if disabled, it would then go and download a return shell, and we can get a shell from the Windows host on our parent machine. Okay. We're going to take this concept one step further. All right. So looking at the attack flow here, let's break this down, what we're going to do. So we have this dropper.ps1 file, and that is going to function very similar to the bat file we created in the previous scenario, except it's going to perform its actions a little bit differently. So let's say this dropper gets executed. What is it going to do? First, it's going to download keylogger.ps1 and exfil.ps1. And then once those files are downloaded, it's going to add those scripts to the registry, specifically current version run, which triggers anytime the user logs onto the machine. Okay, so if the machine gets rebooted, it'll kick off those scripts. The keylogger will start running, and the exfil script will start running as well. Okay. All right, so what happens after that? If we look at keylogger.ps1, and we'll walk through this more in the next video, but it essentially outputs a keylogger.txt, which houses all the keystrokes observed from when keylogger.ps1 gets executed. Okay. And then our exfil.ps1 script, we're going to run a couple different commands. We're going to grab system information, and we're going to download the browser history file. And again, we'll delve more into this in the next video in terms of how these kind of functions work. But just think of it as these scripts are creating different text files or files that we can then ship off to our parent OS machine. Okay. So just think of it as data generated from scripts. All right. And then the exfil.ps1 file, after a certain amount of time, it will zip that data up. And then once that data is zipped up, it's going to be sent to our parent OS machine through FTP. Okay. And there we have it. That is going to be our third attack scenario here. So this is way more hands-off, less involved than our previous scenario. Okay. There's not going to be any hands-on keyboard on the victim box. As long as the dropper.ps1 gets executed, all of these actions will execute essentially autonomously. Okay. And then digging into the detection flow here, we're going to create 4 separate alerts. We're first going to alert on when these PS1 files get added to the registry. Okay. Second, we're going to create some alerts based off of system info and browser history getting manipulated. Okay. We're going to have another alert for when this data gets zipped up. And then we're going to have our fourth alert on the FTP activity and the data getting exfil. Okay. At a high level overview, that is what we're going to accomplish in our attack scenario 3. Then in the next video, I am going to walk through all this in more detail, where to find the scripts that are online, what these different commands are that are going to facilitate all this activity. Okay. And then in our third video, we're going to wrap all that together, put it in a couple different PS1 files like you see here, and then we're going to execute the attack, review it, create our detections, and then make sure they work. All right. I hope you enjoy this section. I'll see you in the next video. Hello, and welcome to the next video. In this video, we're going to do some staging for our attack. Make sure we understand the different scripts that we're going to be utilizing, the different commands, the browser history, all that fun stuff we'll dig into more here before we just start into the script writing. Okay. So to start, we have this keylogger.ps1 file, and that is not something we're going to be writing in this course. Writing a keylogger would be a good bit out of the scope. Okay. But if we go to GitHub, we can see a user by Secure the Logs wrote the simple keylogger that if you execute just the PS1 file, it saves all its data to a keylogger.txt. Okay. And we are actually going to edit the default location. But what we want to do is host this on our parent OS machine. So we can navigate to our machine here. We can use wget as our command. Going back to our browser, what we can do is view the role of this file here. And this saves the keylogger.ps1 into a file that we can then manipulate. And if we go into this file, you can see that the path right here is where the keylogger.txt is going to be stored. And to give a little bit of a spoiler on how we're going to accomplish our data exfil, we're going to save all the data into a folder we're going to create. Okay, so in C Windows temp, which we used in our previous scenario, okay, we're going to create a folder called exfil. And that exfil folder is going to contain all the information that we're going to have to package up and then ship back over to our parent OS machine at the end of the exfil.ps1 script. Okay. So for now, we just need to make sure that path is set. And we can save the file. And at this point, we can consider our keylogger.ps1 file staged. Okay. And what we can do to test this file, just to make sure it's working before we start incorporating it into our scripts, okay? So let's go grab that file, open a PowerShell prompt. Okay, and let's save it to that directory we used in the previous scenario. All right, so we can see our keylogger.ps1. And let's execute this. I forgot to create our path. We could do mkdir for make directory, create that exfil directory that we know we're going to need to look for. And let's run it. So if you see, the PowerShell just kind of hangs here. Okay, and that's because the keylogger is actively working. What we can do is a couple different things. Let's first open up this bat file from our previous scenario. Let's create some new lines here. And if we go into our exfil directory, you can see we have a keylogger text file. And let's type something in here like testing keylogger. Okay. You can see the actual character returns that we did from going from pause down to line 6. All right. And you can see texting keylogger here. All right. And the formatting can get a little bit wonky with keyloggers. Okay. How they display different kind of ASCII characters and things like that can vary a little bit, but by and large, the text is here. So for example, if I went on a banking website or entered in SSH creds or something like that, that would appear in this keylogger.txt file. All right. So that was a quick demo of the keylogger. The next interesting piece to look at on this box is the history file. Okay. And each browser has its own kind of history file, and they can be stored in different locations. Okay. But we're going to use Edge in our example. And let's go to a random website. Okay. So if we go to Google, and let's say we search for MITRE, and let's say we click on the Wikipedia article for MITRE. All right. This is something we're going to search for in our history file once we grab it. Okay. And the history location depends on whatever browser you're running on. For Edge, we're going to go to See Users, to the current user. We need to make sure we can see hidden files because we need to go to App Data. Okay, so we can hit Show and Hidden Items. You can see App Data here. Let's go in here. We're going Local, Microsoft, Edge, User Data, and Default. Okay. And in this folder, if we keep scrolling down here, you can see a file called History. Okay. And this contains all kinds of stuff that we're going to dig into here. And let's throw this on our desktop just so we can easily access it. Okay. Now, if you notice, it's just called File. It's not accessible through any kind of normal means. Okay. If I try to open this in the terminal or Notepad or anything like that, it won't execute properly. But essentially what these are SQLite databases, and we can actually manipulate them. And we can use something called DB Browser. And let's download this. This part is a little out of the scope of this attack scenario and course, but I would hate to show you the history file without actually what it looks like when viewing it. Okay. So let's just get this installed. All right, and going to our history file here. Let's open DB Browser Lite. We can actually drag in this history file. All right. And taking a look at this, we can see URLs, metadata, downloads, all kinds of good stuff here. Okay. But what we want to do is not look at the database structure. We want to browse the data. And then we can filter based off of the table what we're looking at. All right. So let's say we want to find that Wikipedia page. So let's go to URLs. And if you look, see all the URLs I visited on this VM. Okay. If we scroll all the way down, you can see the last couple visits here, and we can see the Google search, and we can see our MITRE Wikipedia page. Okay. So this can be pretty handy if you're an attacker and trying to get some information about a host. If you just think on the average user at work, how many different websites I go to, that might give some hints about the environment, some links that the attacker can possibly pivot to. Okay. And there's all kinds of good stuff in here. You can see downloads and what was downloaded on the host. Okay. So you can see all the different items from the course so far. Okay. So you can get all kinds of good information on here from a response perspective, but also from an attacker perspective. All right. And that is history files and how to access them. Okay. Okay, next up is a pretty simple example. So what we want to grab in addition to the history file is system information. And the easiest way to show this is just by running the command. It's very simple. You just execute it, and it gives all kinds of stuff about your box. Okay, it gives you the name, the version of the OS, the hotfixes, okay? And this is helpful from an attacker perspective because you could use this information to figure out based off of the hotfixes that are installed, but maybe there's potential Windows exploits that could be run, okay? And again, that's getting a little outside of the scope of this course, but it's helpful to know that this command exists, okay? And in our example that we're gonna be working on in our next video, we're just gonna output that information to systeminfo.txt, and then that will get exfilled in addition to the history file, okay? So for now, that's all we need to know from a Windows perspective. So let's move over to our Parrot OS machine. What we're gonna do is get our FTP server installed and running, okay? So with the shell, we're gonna install vsftpd. And we're going to let this do its thing. Should be pretty quick here. All right, next up, we have to edit some of the configuration. Okay. And we're going to do sudo nano etc vsftpd.com. Okay. And what we have to do is allow FTP writes. Okay. So right here on line 31, you can see write enabled equals yes is commented out. We're just going to remove that comment there. Hit Control or Command X to save, Y enter. That saves off the file in Nano. Okay. And then we're going to do sudo systemctl restart vsftpd. Okay. And that'll restart the service. To test this very quickly, what we can do is FTP via our localhost. And we don't have that installed. Okay, so we're going to have to do is install that as well really quickly here. All right. Let's try that again. Okay, so you can see we connected. So the vsftpd server is running. And let's log in as Parrot. Now we're going to give our Parrot password. Okay. In an ideal world, you would create a different user that would only have access to the FTP server, and you would use that for the exploit if you're trying to be sneaky and lock down permissions. So not anyone that grabs this data can do whatever they want on your attacker box. Okay. But for this course sake, this works perfectly fine. Okay. So at this point, we at least know that our FTP server is running and that we can log into it. Now, by default, it'll just serve this folder. Okay, so whatever we throw into the FTP server will just pop up in this local directory here. All right, and we're going to test this from our Windows box. So let's get our Windows prompt open. Okay, and let's close out this keylogger. Let's get a fresh shell in here. All right, so how do we send data via PowerShell? Okay. So we have this history file. Let's say we want to send this history file to the FTP server. Okay. So we're going to write a little bit of code here. And let's create a new text file. And we're going to call it FTP POC.ps1. All right, let's edit with Notepad++. And I'm going to just copy and paste this code in here, and then we can walk through it. It's actually not liking we created it that way. You can see it's doing a double extension here. Let's fix that really quickly here. There we go. So now we have our PowerShell FTP_POC. All right. And using the setup here, you can see that we're instantiating this client, and then we're putting credentials into that. Okay, so you can see parrot right here. And then what we want to say is something like this. So we're saying upload file, the FTP server, and the name of the file on the server once it's uploaded, and then the location of the file that we want to upload. All right. So let's save this. If you see, we now have this FTP PS1 file. Let's just get rid of the other one in here. And let's run this and see what happens. So you can see no data returned back, but if we go into our parent OS box, we can now see that history file was successfully transferred over. Right now, I'm going to delete that file, but that was just an example of how we can use FTP programmatically within PowerShell. Okay. And this essentially lays the groundwork for everything that we need to do with our attack. Okay. We understand the keylogger, we understand FTP, we have our FTP server running, we have POC code. Okay. We understand system information and browser history files. Okay. So at this point, we can end the video and start running our malicious code in the next video. Thank you for sticking with me, and I'll see you in the next video. Hello and welcome. In this video, we're going to use everything that we've learned so far in this course and create this last attack here. Okay. So to start, let's work on our dropper file. All right. And if you remember, the dropper is going to download the keylogger and Exfil scripts and then add those scripts to the startup registry. Okay. So what we can do is let's go into our editor here and let's create something like dropper.ps1, and it's going to be a PowerShell file. And we're good to go to start here. Okay. To start, what we can do is kind of steal from our bat. All right. In our bat file, we had to explicitly say run PowerShell. For us, we don't need to do that. We can just grab our if statement. Okay. Let's throw it in here. Let's throw in some word wrap to make this easier. All right. So we can now start thinking of this more like Python or programmatic language versus just a bat file and list of commands here. So what we can do is edit this a little bit. We don't need these extra trailing characters here. Okay. And now what we could do is add our command sequentially in this chunk right here. All right. So because we're using PowerShell in our bat file, it translates very easily into our dropper. Okay. But instead of using shell.bat, we're going to grab that keylogger. Okay. And we're going to output to keylogger.ps1. Okay. The key here is we're not going to execute it right away. All right. So we still need that semicolon, but we can hit enter for our next command here. Okay. So the next command will actually be our Exfil script, but we haven't written that yet. So I don't want to jump the gun here, but what we can do to showcase how this dropper is going to work is stick with the keylogger for now. All right. So once we have this keylogger downloaded on our box, we can then add that file to the registry. Okay. And what we're doing is saying in Windows current version run, we want to add a key value pair of keylogger and then this command. Okay. Essentially what we're doing here is we're saying PowerShell.exe, hide the window once it executes, and here's the file to execute. All right. So let's see what this looks like. If we minimize our screen here, we can right-click our dropper, run with PowerShell. You can see really quick there, it said this operation completed successfully. All right, and what we should see is a couple different things. We should see in temp, our keylogger PowerShell file here. And if we go into regular, under HKey current user, software, Microsoft, Windows, current version, run. Okay, this executes whenever the current user logs into the machine. We can see our keylogger key value pair is here. All right, you can see our script represented here. All right. So what we're going to do to test this out is restart our virtual machine and then make sure that keylogger.txt file exists in this temp exfil directory. Okay. Okay, now that we got our virtual machine rebooted, let's go into that directory. And there we go. We can see that our script executed upon the host getting rebooted. Okay. And that's exactly what we want. So going back to our dropper. The next thing we would need to add is our exfil script. The problem is we haven't really made that yet. Okay. So let's get that working here. Let's call this exfil.ps1. Okay, so we want to do a couple different things with this exfil script. Okay. First off, as an easy win, we want to run the system info command. And we're going to output that to a very specific directory. Okay. So now if we ran this exfil.ps1 script, it should generate system information in our exfil folder. Let's run this just to check. And there's our data. Okay. So we know that works. That's an easy win that accomplishes 1 out of the 3 pieces of information we're trying to exfil. Okay. So now what we need to do is grab the history file. Okay. And this one's a little bit trickier in PowerShell because theoretically we don't know what this user is called. So when we navigated right to that directory that is under C users and then the user that's logged in, okay, this user could be anything, right? It could be your first initial last name or your first name or something completely nonsensical. Okay, this could be anything. So what we need to do is obtain a command that grabs this user and then we can build it into our file path. Okay, so how do we do this? Well, let's open up a prompt here, and in the PowerShell environment, we can grab the username and we can see user comes up. So this variable can be used to build our file path. Okay. So what we can do is create a variable called browsing history file path, and we're going to build it here. So we're saying C:/users plus the username. Okay. And this is dynamic since it doesn't matter what host we're running it on. It will grab that current user in the environment and throw it in here. And then it's going right to the history file. Okay. And what we can do is do something like this. Okay. So now we are copying this file through that dynamic file path into our exfil directory. And what we can do is try this out. So let's go to our exfil directory, and now let's rerun this exfil.ps1 script. Okay, and now we have a history file. So this part essentially concludes the piece where we're aggregating all the information we want. The next piece is this keylogger. Okay, so if we run all this on startup, and this is instantaneous, the keylogger doesn't have time to do its thing and to gather keystrokes. So what we can do in this attack is say, all right, well, why don't we wait 10, 30, or 60 minutes? Really, it could be whatever we want. Let the user click around, log into things, and then ship that data off. All right. So what we can do is use a command called start sleep. And it goes by seconds here. So if we were to use this in a real example, I would say maybe something like 500. That might be 5 minutes. So we're simply just going to say 5 seconds because we're still building our script and we don't really want to wait too long, right? So right now we're just putting this in as an example. All right. And what this looks like is you'll see this PowerShell window hang. And after 5 seconds, you'll see system information start generating and it's going to regenerate this data. Okay. So now that we have that taken care of, what else can we do in here? The next part is to zip all this up into a file. Okay. And to do that, we can use a command called compress archive. And we have to give a literal path. And then we have to give our destination path. Okay. So let's try this now. So let's do something for fun here. Let's delete this info. Let's delete the history file and let's rerun this. Wrong script. It's going to wait 5 seconds and then start executing all that code. If we go up a folder, you can see we now have an exfil compressed archive. And if we go into it, we can see all the data that we wanted to exfil. So pretty simple. And we're just going to delete that for now. So last step for this exfil script is to ship the data off. And luckily for us, we've already done this. Okay, so if we go into our FTP POC right here, we can simply just grab this data, chuck into our exfil script, and essentially call it a day here. All right, but instead of history, we want exfil.zip. And instead of this path, we're going to grab this path. Okay. So let's see what this looks like. If we run this, again, we'll have to wait 5 seconds. Let this do its thing. Okay. And now, if we go to our parent box, we now have an exfil.zip. And let's see what that looks like. And there is the files. Okay. And you can see all the system information data. So at this point, let's clean this up here. Okay. Don't want to muddy the waters too much here. So at this point, we have our exfil script written. All right. But we can't have it just hosted here, right? This is something that we're going to have on our parent OS machine. Okay. So what we can do is create our file and paste our data in. And let's save this off. We now have our exfil.ps1 script ready to go. All right. And now what we can do is actually just delete it from the system entirely. Okay. We only really need the dropper. All right. And well, let's delete our zip here. Let's delete all this data. Okay. So in our dropper, we have one last key piece of information. Okay. We need that exfil directory. So in our dropper, we want to get that directory created. So we just say make directory. Okay. So we can create our exfil directory here. And now what we want to do is also grab our exfil.ps1 script. All right. We're also going to add it to the same place in the registry. So at this point, our dropper is essentially complete here. All right. So the attack scenario is kind of assuming that whether it's like a drive-by download or PowerShell commands hit it in another file, the initial access piece doesn't really matter for the sake of this course. Okay. We're more interested in what happens after the user executes that initial file. Okay. So what we can do is just run this dropper. And what you'll see here is the dropper create the folder that we care about here since we just deleted it. All right, so we have our Excel folder, we have our files downloaded, okay, and just to check the registry, let's make sure the values that we care about are here, okay, and we can see our exfil script and our keylogger ready to go. All right, so let's reboot our machine and we'll see what happens. Okay, so now that our machine is booted up, let's give this some time and let our scripts do their thing. Just for fun, we can navigate to that directory to see them perform their activity. All right, so we can see we have our zip file here. So theoretically, we should be able to go to our parent OS machine, and there is our exfil.zip with all the files that we specified. Okay. And this successfully concludes our attack scenario 3. Okay, we've gone through all the configuration and got our attack setup created and executed. Okay. This video is getting a little long here, but in our next video, we are going to look at the logs in Elastic and see what kind of detections we can generate off of this data. Okay. I hope this has been helpful. Thanks for sticking with me. I'll see you in the next video. Hello, welcome to this video. In this video, we're going to create some detections and go over the logs from the attack from our previous section. Okay. Since we're a little bit more familiar with Elastic and how to query the logs and how to create the detections, I'm going to go a little bit faster here. So instead of having multiple dedicated videos to reviewing the logs and then creating the detections, we're going to do all that in one video here. Okay. We're going to look at this through the lens of these 4 scenarios here. Okay. So looking at the registry activity, looking at files getting added to the Windows temp directory, data getting zipped up and then shipped over via FTP. Okay. Okay, so let's do a pretty generic search here. So one of the key pieces of information in our dropper was that current version run key. Okay. What we could do is just search current version, and that should return back some hits here. Okay. And now what we can do is hone in on what data set we care about. We can see a lot of these are in Windows System on Operational. So let's pick that one. And now let's dig into the event.actions. And we can see our registry value being set here. Okay, so that's something we definitely want to see. And you can see by hits, we're narrowing it down quite a bit here. We started off with a couple 100,000, now we're at 64. Okay. So let's make this a little bit more clear to read. Let's open up one of these values. Let's filter on the process executable. And then we want the key and path, okay? All right, now we can see all our hits here. We can start getting a little bit more specific. So we know the current version is part of the registry key and not the path. And we're looking at current version run. And this really gets us where we need to go here. Okay, so we have our exfil and keylogger items here. Now let's dig into one of these files. And this is a field I like a lot too, so the registry.data.strings. Let's add this to the table here. So if we were just looking at anything added to current version run, this would be a perfectly fine alert here. Okay, but what we're going to do is narrow this down a little bit more. Okay, so what we're going to do is clear out some of these filters, and I have to walk you through this search here. Okay, let's run this just to make sure the data populates how we expect. All right, so what are we looking at? We're looking at the specific data set, the specific action of the data set. Okay, so we're getting pretty granular into the logs here. And then we're looking for Microsoft Windows current version run in the registry path. Okay, which we can see right here. And then we're looking for specifically PS1 files getting added to the registry data strings. Okay, so this is actually looking for suspicious PowerShell getting added to the current version run registry path. Okay, and this is a pretty strong detection here. So what we can do is work on creating this. Let's navigate to security and manage. I'm going to create a rule. And once this loads, let's grab our string. Similar to our other alerts, we're going to suppress on host.hostname. All right, we're going to do it for 5 minutes. And for a rule name, we can call it suspicious file added to registry. And then for description, we can do something like this. So this alert looks for PS1 files added to auto run on boot up locations in the Windows registry. All right. As we're just going to leave all the same. And under advanced settings, what we can use is the boot or log on auto start execution, specifically on the registry run keys and start folder. Okay. And we're going to call this tactic persistence. All right. And there we go. We're running this 5 every 5. And we're going to create and enable this rule. Okay, this first one's good to go. Let's now look at our second example, which is suspicious files getting written to the temp directory. Okay. And what we could do is clear this out. And let's search on something kind of generic here. Let's search on a history file. And we can get rid of some of these pieces of data here. Okay, let's look at some of the event actions. Maybe we can have a file create or something along those lines. You can see a couple interesting things here. So execute remote command, pipeline execution details, and executing pipeline. These are all in relation to the PowerShell script. So we don't exactly want to alert on that, right? We're more concerned about the actual creation of the file versus just code contained within a script for now, okay? So creation and overwrite are the two that are sticking out to me, okay? And let's see what this looks like. So this is part of the endpoint events.file dataset. Okay, so let's say we want to take a look at that. We have one log here. Okay, now let's make this a little bit more easy to look at. We can see the file path here. And ultimately, that's all that we care about. But this process.name is really interesting too. Okay, so let's add these to the table here. So we can see that this file specifically was created by PowerShell.exe. Okay, and that's a good way to narrow down on false positives. Okay, so if someone is manually moving around files, you don't have to trigger on every single one of those. Okay, so if you can narrow down on the specific scripting language or framework that you're working off of, that's very helpful. Okay, so essentially someone have to write a PowerShell script to then move the history file. And that's a great way to narrow down on false positives. Okay. So we want one more field in here. Let's put in file name. All right, so now we have our history. Now what about those text files? Okay, think sysinfo.txt or the keylogger. Okay, those are all potential suspicious files. Okay, so let's search on those. All right, so now we get all kinds of good stuff back. We can see all the files created with .text or the history file. And we can see the three that we care about, but we also see a bunch of stuff that we don't. Okay, and these were also created by PowerShell. Okay, so that just searching on PowerShell won't help us out here. But what can help is searching specifically on this directory. So what we can do is wrap all this up together based off of the data sets that we know about and the searches that we came up with here and in the previous alert. And running this search, you can see that we're looking at creation or overwrites. So as the attack continues to operate, the history file might keep getting overwritten in the next field, okay, and getting updated essentially with the latest version that will contain all the latest user activity, okay? And then we're looking at PowerShell as the process name. And what helped us tune out all the other PowerShell activity before is searching just on Windows 10, okay? And then we're searching on the file name that we discovered in our initial searching. So this is essentially alerting on what we care about here, okay? So let's turn this into an alert. Let's go to manage. And let's create a new rule here. Let's grab our logic. And again, we're going to suppress by host name. We can call this suspicious file written to temp. All right. For description, we could say this alert looks for both specific files and file extensions written to a file path containing Windows/temp. Okay. And under advanced settings, we can actually have two MITRE tactics and techniques that are applicable to this activity. All right. First off is system information discovery, and this is that sysinfo that we worked through in our last video. So looking here, we have discovery. And let's add this in here. Okay, we have another tactic and technique, but it is still under discovery. Since we're grabbing the browser history, we might be able to consider this browser information discovery. Okay. Which is interesting, because we notice here, there's actually discrepancy between what Elastic has in their product versus MITRE itself. So MITRE calls this browser information discovery. Elastic calls this browser bookmark discovery, and it's the same TID. Okay. Well, we're just going to leave it for consistency's sake. All right. But the general essence there is that we're grabbing some browser data. All right. And scrolling down here, we can still do our normal 5/5. And let's enable this rule. Looking at our diagram here, next up is this zip activity. All right. We're actually going to reuse quite a bit of our previous search here. So looking at our new search, we essentially kept the same chunk here where a creation or overwrite is occurring, except this time it's on a zip file. Okay. And if we run this, you can see our exfil.zip. So if anyone's doing any kind of activity on Windows temp, this should pick that up. Okay. Whether it's the previous alert where there's suspicious files getting added to this directory or the zip itself. All right. We could use this as a means of detecting that local data staging. Okay, so let's create that rule quickly here. You'll notice there's a common theme here based off of our suppression and timing. And let's call this data archive for potential exfil. And we can say this alert is looking for zip files being created in a file path containing Windows 10. All right. And then for the MITRE attack, tactic, and technique here, we're going to do data stage, local data staging. Okay. This technique is encompassing anything involving aggregating data and packaging it up for exfil. Okay. So this is under collection. And this is data stage, local data staging. And scrolling down here, our normal 5/5, and we can create and enable. Okay, so we have 3 of our rules here, and we have one more to look through. And this one's a little bit tricky. Okay, so looking at our diagram here, we want to alert on the FTP activity. FTP is not commonly used protocol. Okay, it's essentially sending everything in clear text. SFTP would be more secure, where it's encrypting the data in transit. So anything FTP related is likely pretty suspicious. Okay, but we still want to be a little bit particular. Okay, and we're going to walk through a couple examples on how to figure out what's going on here in the logs. Okay, so first let's clear these here. What we can do is maybe look at the script that's getting executed. Okay, so if you remember in our exfil.ps1 file, we had that 3 lines of code that essentially created the FTP request and shipped it off to parent OS. Okay. And there's different ways of figuring that out. So let's say we want to look at FTP data. Okay, so if we open up any one of these, scroll through here. So sysmon automatically logs all PowerShell scripts into a script block. Okay, this is because of the configuration that we set earlier in this course. And looking at this, we can see we have FTP and the .zip. Okay, so if we wanted to alert on script contents, that's one good way we can do this. Okay, and the search we can do to take advantage of this is something like this. So we're looking in the script block. If you notice here, it has to contain this FTP start here and then .zip somewhere in the script as well. Okay, this could lead to some false positives if zip isn't right in this FTP string or something along those lines. Another problem is there's any kind of obfuscation within the script, this would trigger on that activity. Okay, so I'm not 100% sold that this is quite the way to go. Okay, so what we want to alert on is not as much the script contents and more about the network activity. Okay, so one way to do it is maybe just searching on something like FTP and then seeing what kind of event types that we have to work with here. So if we look at our data sets, you can see some Zeek activity, and then you can see some Windows sysmon activity. Okay. And first we're going to dig into the sysmon activity. So let's look at the event actions. We have remote command execution. That's our PowerShell. We have PASV and SDOR, which is related more to Zeek activity. Okay. But then we have this network connection detected. Now let's look at this one. So if we dig into one of these logs here, when we scroll down, we can see network connection was detected, and this is in Windows sysmon operational. Okay. So think of this as a local log that's showing network information, which is interesting. So if you don't have something like Zeek, you can still sometimes get the network information that you want. It just might not be as verbose as Zeek. And we'll see that here in a second. Okay, so we have network protocol is FTP. Okay. But if we look through the logs here, there's no mention of that zip file. We can see PowerShell facilitated the FTP. Okay, but if we keep scrolling through here, there's nothing. And just in case, we can go to the JSON. And if we wanted to, we can control F for .zip. And there's no hits. Okay. So this isn't as helpful either. Okay. Unless we wanted to alert on any single FTP connection. Let's say that is considered just an insecure, unused, and not allowed to be used in your organization. You know, that's something you can do to help police that, but it's not really something we're interested in. Okay. So let's back this up. So now we're searching on FTP activity as determined by Zeek. Okay. And looking into these logs here, let's see what we get. So let's table out the event action. Going down here, some interesting things. We can see the related user. And we can see the ftp.arg, which is definitely something we hear about. And we can see the transfer status. All right. So going back to our logs, we can see this STOR contains all the ftp.args that we care about. Okay, so what we can do to help construct this alert is just say something like this. All right. And now we see all the attempts from our testing today. And I might have more logs than you all from just testing on my end before recording the video and things like that. So don't worry if you only see one or two of these hits. Okay, so the key here is we can see confirmed FTP traffic and we can see the file that is getting sent over. Okay. And what we could do is something like this. Okay. So at this point, we have a much better alert here that shows exactly the file getting sent over by the file name that it's getting saved to. Okay. So now we can make this an alert. Let's save that off. If we look here, we're going to suppress via the destination address. So if the attacker doesn't, let's say, zip up the files in this way, or they zip up multiple different files, and those are all individual files getting sent over, we're not going to flood response with 100 or 1,000 alerts. Okay. Let's call this data exfiltration observed via FTP. And then this alert looks for zip files being sent over FTP. For the MITRE tactic and technique, we're looking at automated exfiltration, okay? And there's a couple different techniques that this could potentially apply to. For example, exfiltration over C2 channel will be another good one, okay? But since we set up this exfil based off of a script that requires no interaction from the attacker outside of just getting the user to execute that dropper, okay? We're going to call this automated exfil. And this is under exfiltration as a tactic. So what we can do here is set that up. 5/5. And let's create and enable this rule. All right. And that concludes the rules that we wanted to create out of this attack scenario. If we look back, we can see we have our 4 alerts that line up with the 4 different scenarios we wanted to account for. Okay. So that's going to wrap up this video. This is running a bit long here. I hope this has been helpful. In the next video, we're going to run our attack and then make sure they generate. Thanks for sticking with me. I'll see you in the next video. Hello and welcome. In this video, we're going to close out our 3rd attack scenario here. So we have our 4 alerts that we created in this scenario, alerting on all this activity from the dropper, the keylogger, the exfil script, etc. Okay. And what we're going to do, since this is all essentially automated, is just reboot our Windows 11 machine, and then we'll hop back in Elastic and I'll walk us through the alerts. All right. I'm going to kick off this reset. I don't want to waste too much time on this video, so I'll fast forward to when the alerts start flooding in. All right. Okay, circling back here. What I did was reboot my Windows 11 machine and then gave it some time for our attack to populate, and then the logs getting sent over to Elastic, and then Elastic having their rules generate here. Okay, so we can see our detections all triggered as we expected. Okay, what's interesting to note here is that they were out of order in terms of how the attack flow works, and that's due from how the rules were created and the different increments of that 5-minute span for each of the alerts. Okay, but ultimately we're detecting everything we need to detect, and the response team would potentially have some different key pieces of data to look at for the attack. Okay, and we could dig into each of these individually. Okay, and let's look at our suspicious file added to registry. And let's actually look at this in the Analyze Event tab. And once this generates, you can see that PowerShell executed. Okay, and this was via the dropper.ps1. And then a registry was added. We are manipulating Windows current version run under the current user. We're adding the keylogger with the value of PowerShell.exe -Windows style hidden, and then the file. Okay. So that's all very helpful. Now let's look at suspicious files written to temp. And in this scenario, it's only triggering on one of those 3 files. Okay. So first it detected the keylogger.txt. But if we scroll down a little bit, you can see 2 suppressed alerts. All right. So that will give some impetus for the response team to go figure out what else was happening around this activity. Okay. And then moving on to our next alert, we have data archive for potential exfil. And let's check this out. So we can see right here in the alert summary, we can see the exfil.zip getting created. Okay. And last but not least, we have our data exfiltration observed via FTP. And we can see all the related network information here. We have the source IP, source port, destination IP, desk port. Okay. And we even see the parent user that was used, which is interesting. Okay. What's interesting to note here under these rules tab, speaking in terms of the suppression rules, this little icon here lets you know if there was more activity surrounding this alert, but it was suppressed. Okay, so this would be a very obvious indicator for a response analyst to come in here, check it out, and look at the related activity. So at this point, we've accomplished everything we set out to do for this attack scenario. Okay, we got our attack working, created some alerts, tested the alerts out, and made sure that they were successful. All right, that concludes our scenario here. I hope you've enjoyed this section. Thanks for sticking with me, and I'll see you in the next video. Hello, and welcome to our section on Atomic Red Team. In our previous videos, we went through some attack scenarios, and that was the best way to replicate how a detection engineer can go about creating alerts on incident response activities. So in a corporate environment, you have incident response. They'll go through their analysis process, and they might have given you some of the hints or leads that we went through in the attack scenarios. Okay. But what about if you're on the job and there's no live incidents coming in, there's no hunts coming across your desk? How do you go about making use of your time and creating detections? The best way is to use some kind of attack framework, whether that is Atomic Red Team, which is a great free option. There are also paid products that tick some more complex boxes. Okay. But ultimately, the main goal is to run a test, see what happens with the test and the logs, and then create detections off of our tests. Okay. You can also use Atomic Red Team for unit testing. So let's say we do create an alert from an incident response activity. We can also create a unit test to get that activity to trigger again through Atomic Red Team. So outside of just calling Atomic Red Team attack framework, what is it really? Okay. So think of it as a repository of different tests that can get run on a host. Okay. So if we look at the attack matrix, you can see all kinds of different techniques. And looking at our enterprise matrix, what can we look at? Okay. So we had, and some of our examples that we were using for Elastic and those sample alerts, we had some audio capture. Okay. And that is under collection. If we look at here, and then we have audio capture. Okay. Let's say we want to run some tests and then make detections off of this audio capture technique. What we can do is look at collection. And let's go into Atomic Red Team here. You can click Atomics, go to Collection, and then look for audio capture. All right, scrolling down, you can see that the supported platform is Windows, which is great because that's what we're going to run Atomic Red Team on. Test number 2 is also Windows. And test number 3 is QuickTime Player. Okay. So when navigating Atomic Red Team, you can think of a one-to-many relationship between one technique. Could have any number of attacks built into it. Okay. And you could also write your own atomic tests as well as your department gets more mature. Okay. So what we can do is look at the GitHub for Atomic Red Team. And let's find these same atomics. We can search T1123. All right, so we have audio capture, and we have these same atomics here. Commands that are run. Okay. And this all looks identical to their documentation in here. The big thing with the GitHub versus their website, while the website is pretty slick and easy to read, their GitHub contains the code that actually gets run. So if you notice what the file here, that's all in Markdown to show you the same information that's on the website. But if you go into the folder and go onto the YAML file, you can see the actual commands that are getting run and how they're getting run. Okay. You can also add in your own tests in here pretty easily. You could just tack on another name section on here, add your own commands, add some cleanup commands, name it whatever you want. Okay. It's a pretty seamless process. And we're going to use this atomic as our test case in a little bit here once we get it all installed. But for now, I think we have a good overview of what Atomic Red Team is, what we're going to use it for. Okay, just think of it as a testing framework where you can hit a couple commands on a box and automatically run some tests. So in the next video, what we're going to do is install Atomic Red Team on our Windows test VM. Then we're going to run our tests. And then what we're going to do is create our own atomic. And then we're going to run that test. I hope you're looking forward to this section. I'll see you in the next video. Hello, and welcome to our next video, where we're going to install Atomic Red Team. Well, there's two ways you can go about it. You could just download this repo and work off that repo, okay, but they actually created a neat framework that we can use to install and utilize Atomic Red Team. And if we go to the Atomic Red Team GitHub, you can see down here, it says, for a more robust testing experience, consider using an execution framework like Invoke Atomic. And that's what we're going to do. Okay. So going down into Invoke Atomic, essentially this is allowing us to test a lot of our techniques through the command line. Okay. So we can go to installation and uses instructions. And let's go to the installation page here. Okay. So this is pretty simple. We can simply just copy this command, go into our Windows 11 machine, paste the command in, and we're good to go. We'll let this install. It shouldn't take too long here. So this is installing the Invoke-Atomic Red Team module for PowerShell. Okay. This isn't actually downloaded the atomics, and we're going to do that in our next command, which if we go to the instructions here, let's scroll down a little bit here. Let's say we want to get the atomics. We can take this link. Okay, so now it says we're ready to go to use Invoke-Atomic Test. So what did this do exactly? Well, first install that atomic test framework, but also it downloaded this folder called Atomic Red Team, and contained within this folder is this atomics section that has every single technique and the associated tests. Okay, at this point we have Atomic Red Team up and running. We have all our atomics downloaded. Okay, and that's going to be it for this video, but in our next video, we're going to run our first atomic. I'll see you in the next video. Hello, and welcome back to our next video. In this video, we're going to run our first atomic. Okay, so looking through the attack matrix here on our Windows VM, what we can do is scroll over to collection, and we're going to run audio capture as our example for this video. But after you finish the Atomic Red Team section, you could run really whatever you want. Okay. And going into audio capture, we can see the main objective is to turn on something like a microphone or a webcam or really anything that can facilitate audio. Okay. So looking at Atomic, let's grab this TID and search that in Atomic Red Team. So in this MD file, we can see the commands that are going to be attempted to run. So if we notice we have Windows, and then Mac OS, we're only going to need to run Atomic Test 1 and 2 on our machine because we don't have a Mac OS device to test on. Okay, so looking at our first test, we can see device using the audio capture commandlet. And this is a PowerShell command that facilitates audio capture. All right, so essentially what will happen when we run this test is Atomic Red Team will actually kick off this command. So we should be able to see that in the logs once we dive into Elastic. Okay, and now looking at attack number 2, we can see something a little bit different. Instead of PowerShell executing, we're looking at registry values getting added. And then it looks like the cleanup command is just deleting what was just created. Okay, it looks like it's turning on something regarding the microphone here. And then scrolling down to QuickTime Player, it's attempting to manipulate QuickTime Player, okay, and then creating a file with the recorded audio. But we're not going to run this test since it's not going to execute properly on Windows. If we wanted, we could theoretically run it, and we should see the commands getting attempted to run, but it won't run because these are assuming that you're using Bash, and Windows is going to be kicking off PowerShell or cmd.exe or something along those lines. So let's go onto our box here. We can say invoke atomic test. If we want, we could hit enter and type in the technique we want to test for. But what we're going to do is specify the test. Okay. And if we go to the documentation, you can see you can do the test. You can give the TID. So we're looking at T1123. And we only want the first two tests. Okay. So they can do -1 and 2. Right, and let's give this a go. Okay, our 2 tests ran. And if you'll notice during the second test, we got some access denies. And this could be for any number of reasons. If we ran this activity on an admin prompt at PowerShell, this might have had proper permissions. But for right now, no dice on this test. But we do have this command that was ran successfully. We should be able to see both of these in Elastic. Okay. In terms of running the test, it really is that easy. Once we have it set up, you just write invoke atomic test, whatever TIDs, and then whatever test you want to run. If we were to add, let's say, a custom 4th test, we can add that data into the YAML and then do -4, and that would kick off your custom test. And we'll get to that later in another video. All right, what we're going to do now is pivot to Elastic. All right. And what I'm going to do is also pull up that technique ID and atomic red team. So now we have our commands we can reference in Elastic. All right, what we're going to do is go into our Discover tab. All right, now first up, what we can do is go into our tests here, and let's grab this commandlet string and see what comes up. Looks like we have a lot of commands here. Let's narrow down into the different data sets. We have pretty good endpoint logging from both Elastic and Windows Sysmon. So let's look at Elastic's dataset first through their endpoint.events.process dataset, and we can see 2 entries here. Opening up one of these, we can see the start action, and the other one should be end. Okay, so Elastic lets us know when a certain process starts and stops. So looking at our start entry here, we can see that exact PowerShell commandlet getting run. And an easier way to see this, if you wanted, under popular fields, or if you have to search for them, that's fine as well. You can tack on these different views here. Let's say you want to see the command line. Let's say you want to see the parent process name, host name, things like that. Okay, so you can build out our view and look at the activity. So that's looking at it from the Elastic Agents perspective. Okay, now let's look at it from a different data set. And let's look at sysmon_operational. All right, we essentially see the same data, at least for the specific fields that we're looking at. Okay, but we only see one here, and that's because syslog is just logging a singular command, and it's not logging the start and stop of that command. So there's some nuance there if you have one need versus the other. And just looking at the data, we can see all the same good stuff. We can see that Windows audio device PowerShell command line getting run, and the parent process being PowerShell. And this here is a pretty good search if we wanted to alert on all activity where this commandlet is getting run by PowerShell in the command line. What we can do is filter just on this command line. Okay, so we can say, add this to filter. And we could even say we want to make sure that PowerShell is the one kicking it off. And now that this filter is added, what we can do is save the search. We can use it later, or then use the search to turn it into an alert down the road. Okay, so let's call it audio capture, and then maybe the TID. This T1123. And then we can call it Windows audio device PowerShell commandlet activity. All right. And then we could do the data source. In this case, we're using sysmon operational. And this search is good to go, and save it. And use it for later if we need it. All right, that concludes this test number 1 right here. Let's go down into test number 2, where we have some find registry activity occurring, or at least attempting to be occurred. So let's get ourselves a new search here. And as a basic search, let's just look for any registry activity. So we can see some process arguments in here. If you look, this is the same registry path. Okay, so let's see what data sets we have available. And let's look at it again from both the Elastic's and Sysmon's perspective. So going into the endpoint data here, you can see the activity. Let's see where we want is in the log. Command line. All right, what we could do is add some fields in here to make this a little bit more clear, similar to the last test that we did. So let's look at the command line. Let's look at the parent args, and let's look at the host name. We can see all our activity on here. Put the parent name as well, actually. There's cmd.exe. This is to the left, so it looks a little bit better here. All right, so we essentially have a chain of events here. We have the command line, parent args, the parent name, and then the host name that it's occurring on. All right, this looks good from Elastic's perspective. Let's go look at Sysmon. I have the same activity. We have some data in here that don't have a command line function, and this is most likely triggering on Atomic Red Team doing its thing. So it's triggering on some DLLs here. We're not going to worry about that too much. If you notice, this timestamp is quite a bit behind. This is most likely triggering from when I was extracting Atomic Red Team's folder. Okay, because this is around the time that I was doing that video. But zoning in on just what's occurring recently, we have our 2 registry values here. And technically, we could alert on this. We could just say search for all registry activity and alert on it. That might create a lot of problems if anyone installs any kind of software that's going to create some registry values, and we're going to have all kinds of false positives. Okay, so what we're going to do is filter just on the process command line. And to save some time, I have the query here, but I will walk you all through it. All right, and this filtered on everything that we needed. So if you look at the process.command line here, we're looking at the reg add, except we have to add in a space, which is a little interesting because typically you don't run commands like that on the command line, but we do have to take that into account here. And this question mark is essentially a wildcard for a single character. So a space is technically a character. So this allows the query to run. And then we have to do a bunch of escaping for the registry file path here. Okay, and we're going all the way over to microphone. And what this will do, if we expand this out, it'll trigger on any activity up the microphone. So no matter if this value changes or this value here, it'll still trigger on this alert. And this kind of logic is way more intentional than just searching on registry activity. Okay, so we're going to use this as our search. Let's save this off. We'll start off with the technique and technique ID. We could name it something like microphone registry activity. And then again, we're looking at Sysmon operational. And we can save this off. All right, at this point, we ran our very first Atomic Red Team test. We looked at the data in Elastic and create some saved searches. Okay. And what we're going to do in our next video is create our own Atomic. We're going to run that Atomic. We're going to rerun the test and make sure that alert triggered. I hope this has been helpful. I'll see you in the next video. Hello and welcome to our next video. In this video, we're going to write our first atomic. And what we're going to do is actually base this atomic on our dropper from our third attack scenario. Okay. And thinking back to that attack scenario, if we go into the technique here, we can see it's command and scripting interpreter PowerShell. Okay, so that means we need to add a test under T1059.001. Okay. If we navigate to that section in the GitHub here, we can see that there's a whole suite of tests. Okay. And we're going to kind of ignore all of these. We're just going to take one, add another one on the bottom, edit it, and see if we can get it to run. So now let's go into our atomic section. We can go to Atomic Red Team, Atomics, and we want T1059.001. And if we open up this YAML file in Notepad++, we have listed out all the different ways this technique can be tested. Okay. What we're going to do for simplicity's sake is just scroll to the bottom, and we're just going to copy the very last one here. And what we could do is just kind of edit these values and make it work for us. Okay, so instead of reusing or regenerating this GUID, I'm not too worried about that right now. I'm just going to edit this last character here. For the name, we can really call it whatever we want. We just name it something like run dropper.ps1 code from attack scenario 3. Okay. All right, so we have a light description here. And now what we could do is put our commands in here. All right. And what we could do is just take our code from dropper.ps1. Let's just throw it in here. Give it some formatting. Okay. And now what we can do is execute this and see if it runs. All right. So we can save this file, open up our terminal, run invoke atomic test. Run T1059.001. And we just do dash. Let's see here, what number? So we're at 22 here. We need to do 23. We can see run dropper.ps1 code was executed for attack scenario 3, which is what we call the name. Okay, and it looks like whole list was completed successfully. And what we could do just to test this out is first, we could look at our pair OS machine. And if I resize this here, we can see that the files were grabbed. Okay. And now just to test this out, let's make sure those registry files were added. And if we go into HKey current user, software, Microsoft, Windows, current version, run, we can see our files. Okay. And now what we can do is go into that temp folder. And we can see our keylogger, the exfil PS1 file, and the exfil folder. Okay. But it didn't execute yet. This just executed that dropper. So the keylogger didn't actually run yet, or the exfil. Okay. So this is just a good example with some code we're already familiar with on how to create our own technique tests and then run them through the invoke atomic test. That essentially concludes this video on how to create more technique tests within Atomic Red Team. Okay. The important aspect to note here is if you're going to create a lot of tests, whether it's for your own testing or in your own environment or for the company you work for, you're going to want to fork Atomic Red Team and try to manage that yourself. Okay. Reason being, if you're syncing with Atomic Red Team and their atomics, it might conflict with your additions or even wipe out your additions whenever it syncs back up to the main Atomic Red Team folder. Okay. But outside of that, creating your own atomic is pretty easy, especially if you already have code written. And another key point here is if you find yourself developing atomic tests regularly, I would recommend getting these working on a machine first so you can be confident in their execution. And that way, when you put that data in the atomic tests, if there are any issues, you know it's either with a typo from you copy and pasting it or something like that, or it's a problem with Atomic Red Team and how that's set up versus the code you've written. Okay, because as these tests increase in complexity, you might have some trouble troubleshooting whether it's a problem with Atomic Red Team, a problem with the code you've written, or some combination thereof. All right, that's it for this video. I'll see you in the next one.